Imagine a laboratory where physicists set up one of the most elegant and troubling experiments in all of science, one that has been performed thousands of times across decades and still produces results that seem to violate the fundamental logic of how reality should work. They take a source of light or electrons and aim it at a barrier containing two narrow openings, two slits positioned side by side, and on the other side they place a detector screen to observe where these particles arrive. When both slits are open and no one is watching which slit the particle goes through, something extraordinary happens. The particles behave like waves, interfering with themselves, creating a pattern of alternating light and dark bands on the screen, as though the particle somehow traveled through both slits simultaneously and collided with itself in mid-journey. But the moment the physicists set up a measuring device to determine which slit the particle actually passes through, the moment they attempt to observe the particle's path directly, the behavior changes completely. The particle seems to know it is being watched and behaves like a particle instead, passing through only one slit or the other, and the interference pattern vanishes, replaced by two simple bands behind each slit. This phenomenon persists regardless of how cleverly scientists design their experiments, no matter how sophisticated their detectors become, no matter how indirectly they try to measure the information. The particle's behavior remains fundamentally dependent on whether or not someone is observing it, suggesting that observation itself has a role in determining physical reality rather than merely revealing pre-existing facts about the world. Physicists have accepted this as genuine truth about quantum mechanics, cataloged it in every textbook, built entire industries on understanding it, and yet the core mystery remains unsolved. How can the presence of an observer, merely by choosing to measure, fundamentally alter what a particle does and becomes, and why does consciousness or measurement have this power at all? Imagine two particles born from the same event, separated by vast distances across the universe, yet mysteriously connected through an invisible thread that science observes but cannot fully comprehend. As if reality itself operates according to rules that contradict everything we understand about how the world should function at the most fundamental level. When researchers measure a property of one particle, say, its spin direction pointing up, the other particle instantaneously aligns itself to the opposite state, pointing down, regardless of whether they are separated by meters or millions of miles, suggesting some form of instantaneous communication that violates the very principle that nothing can travel faster than light. Einstein himself struggled with this phenomenon, calling it spooky action at a distance, unable to accept that nature could permit such seemingly impossible coordination between distant objects. Yet decades of rigorous experimentation have confirmed beyond reasonable doubt that this entanglement is genuine and not merely an artifact of incomplete information or hidden variables we have yet to discover. The psychological mechanism that allows us to accept this paradox involves a gradual normalization process within the scientific community, where repeated experimental validation slowly reshapes our intuitive understanding of reality itself, convincing us through accumulated evidence that the universe simply does not conform to our common sense expectations, and that what seems impossible is merely our perspective being too limited. We have learned to live with the cognitive dissonance by compartmentalizing quantum phenomena into a separate mathematical framework that works perfectly for prediction and engineering, even though it describes outcomes that seem to violate the basic logical laws of causality and locality that govern our everyday experience. Consider for a moment the simple act of awareness itself, the fundamental experience of being present within your own mind as you observe the world around you, and you will immediately encounter one of the most profound mysteries that science has yet failed to adequately explain. Consciousness, the subjective experience of sensing, feeling, and knowing, remains utterly resistant to the frameworks we have constructed to understand the physical world. Every measurement we can take of brain activity, every neural pathway we can map, every chemical reaction we can document occurs entirely in the objective realm of matter and energy, yet none of these observations fully account for the actual felt quality of experience, what philosophers call qualia, the redness of red or the painfulness of pain. We can describe what happens in the brain when you see the color blue, can identify the firing neurons and the chemical cascades, and yet the subjective sensation of blueness itself seems to exist in an entirely different dimension, a private theater of experience that belongs only to you and cannot be fully translated or transmitted to another consciousness. Scientists have proposed numerous theories to bridge this explanatory gap, from integrated information frameworks to global workspace models, yet each one ultimately leaves us at the same perplexing threshold where physical process ends and subjective experience begins. What makes this glitch in our understanding particularly troubling is that consciousness is the only thing we know with absolute certainty to exist, the only foundation upon which all other knowledge rests, and yet it remains the most enigmatic aspect of reality we attempt to study. We have somehow normalized this profound failure to understand our own minds by relegating consciousness to the margins of serious scientific discourse, treating it as a problem to be solved rather than confronting the possibility that our current scientific paradigm may be fundamentally inadequate to address it. Imagine yourself walking into a coffee shop you have never visited before, yet the moment your eyes scan the wooden tables, the cream-colored walls, and the particular angle of afternoon light streaming through the windows, an overwhelming sensation washes over you, the absolute certainty that you have experienced this exact moment before, down to the smallest detail, including the conversation your friend is about to make and the specific song playing softly in the background. This is déjà vu, a French term meaning already seen, one of the most common yet profoundly mysterious experiences that occur in human consciousness, affecting somewhere between 40 and 90% of people at some point in their lives. The experience typically lasts only seconds or minutes, but it leaves behind a peculiar residue of certainty mixed with confusion, a mental itch that cannot quite be scratched. The scientific community has proposed several competing theories to explain this phenomenon, yet none has achieved definitive proof. One prevailing hypothesis suggests that déjà vu results from a glitch in memory processing, where the brain's recognition systems momentarily malfunction and misidentify a current experience as something from the past, creating a false sense of familiarity without any actual corresponding memory. Another theory proposes that déjà vu occurs when a present situation closely resembles a past experience in specific structural ways. Perhaps the layout of a room echoes another room, or a conversation pattern mirrors one from years ago, and your brain unconsciously detects these similarities without consciously retrieving the original memory. Some researchers have suggested connections to epileptic activity in the temporal lobes, while others propose that déjà vu might involve attention and memory systems becoming momentarily desynchronized, causing your brain to process current information as though it were already stored in memory. Imagine a world where thousands of people share the exact same false memory, a collective misremembering so widespread and consistent that it feels less like individual confusion and more like a glitch in the fabric of shared reality itself. This phenomenon is known as the Mandela effect, named after the widespread false memory that Nelson Mandela died in prison during the 1980s, when in fact he was released, became president of South Africa, and lived until 2013. The effect describes instances where large groups of people remember events, facts, or details differently from how they actually occurred in recorded history, yet their memories align with each other in remarkable ways. Consider the Berenstain Bears children's books, which millions of people distinctly remember spelling as Berenstein with an E before the I, despite the books having always been spelled with an A, or the common memory of the Monopoly man, Mr. Monopoly, wearing a monocle in his eye when he never actually did. These examples persist despite being easily verifiable through simple research, and yet people insist with genuine conviction that they remember these details differently. The psychological mechanism behind this phenomenon involves how human memory actually functions, which is far less like a video recording and far more like a constantly reconstructed narrative that fills in gaps with what feels most logical or expected. Our brains rely heavily on pattern recognition and assumption, and when we encounter information that fits into our existing mental categories, we tend to accept it as correct without verification. Social reinforcement amplifies this effect dramatically, as when one person mentions their false memory to another, it can actually implant or strengthen that same false memory in the listener's mind, creating a cascade effect through communities and across the internet. Imagine standing at the edge of a vast cosmic stage where the universe performs its most fundamental dance. Yet roughly 85% of the matter that should be there according to our calculations simply cannot be seen, touched, measured directly, or detected by any conventional means available to modern science, and this invisible substance, which we have named dark matter, represents one of the most profound mysteries in physics because galaxies spin far too quickly for the amount of visible matter they contain, And without this unseen gravitational anchor holding everything in place through its immense gravitational pull, these stellar systems should tear themselves apart and scatter into the void like leaves in an autumn wind. The psychological mechanism behind our acceptance of dark matter's existence operates through a peculiar form of scientific reasoning, where we have become comfortable acknowledging the presence of something we cannot observe by simply inferring its reality from the observable effects it produces. Much like how we know wind exists not because we can see the wind itself, but because we witness its consequences on the world around us, and in this same manner. Astronomers and physicists have constructed an elaborate theoretical framework where dark matter becomes as real and necessary to our understanding of cosmology as the stars we can actually perceive. Imagine standing at the edge of the universe and observing something that fundamentally contradicts everything we believed we understood about how reality works. In the late 1990s, astronomers pointed their telescopes toward distant supernovae, preparing to measure the universe's expansion and confirm what seemed like an inevitable conclusion: that gravity's pull should be slowing everything down over time. Instead, they discovered something that has haunted cosmology ever since. The universe is not slowing down, it is accelerating. The galaxies are moving apart faster and faster, driven by some invisible force that works against gravity itself, pushing everything away from everything else with increasing intensity. This mysterious phenomenon became known as dark energy, and it constitutes approximately 68% of all the matter and energy in the entire observable universe. We have named it, measured its effects, and incorporated it into our most sophisticated mathematical models, yet we have no genuine understanding of what it actually is. The psychological mechanism at work here involves our tendency to create names and frameworks for phenomena we cannot explain, which paradoxically makes us feel as though we have achieved some form of understanding. By calling it dark energy, by assigning it percentages and mathematical properties, we gain a sense of control and comprehension that masks a deeper uncertainty. We have essentially labeled our ignorance and filed it away into the expanding repository of cosmic mysteries. Scientists propose various theories. Perhaps it is the energy of empty space itself, or perhaps it represents evidence that Einstein's general relativity breaks down at cosmic scales, or perhaps it indicates the existence of additional dimensions or parallel universes we cannot perceive. Yet despite decades of intensive research, despite the construction of increasingly powerful observatories and the refinement of mathematical frameworks, dark energy remains fundamentally mysterious. What persists most strikingly is our collective acceptance of this unknowing. At the quantum level, something profoundly unsettling occurs whenever a scientist attempts to measure the behavior of a particle, and this phenomenon is known as the observer effect, a glitch in reality that defies our conventional understanding of how the universe should function. When physicists design experiments to track the path of an electron as it travels through space, the very act of observing it fundamentally changes its behavior, causing the electron to behave differently than it would if left completely unmeasured and undisturbed. Before observation, quantum particles exist in what physicists call a superposition, a simultaneous state of multiple possibilities all at once. But the moment a measuring instrument focuses attention upon them, the particles seem to collapse into a single definite state, as though they were aware of being watched and responded accordingly by conforming to a more predictable form. This suggests that consciousness itself, or at minimum the act of intentional observation, plays a role in determining physical reality at the most fundamental levels of existence, a concept that contradicts everything we understand about an objective universe existing independently of human perception and measurement. The mechanism behind this phenomenon remains genuinely mysterious despite decades of rigorous scientific investigation, with physicists proposing various interpretations, including the Copenhagen interpretation, which suggests reality has no definite state until measured, or the many worlds interpretation, which proposes all possibilities actually occur in separate branching universes. What makes the observer effect particularly unsettling is not merely that it occurs, but rather that we have come to accept it as normal scientific fact despite it seeming to suggest that the universe itself is not what we would call real in any conventional sense prior to being observed and measured by conscious entities. Every night without fail, your brain enters a state of profound activity that produces vivid narratives, impossible landscapes, and emotional experiences that feel entirely real in the moment. yet dissolve into fragmented memories by morning, and despite decades of neuroscientific research and countless studies examining the sleeping brain, we still cannot definitively explain why this phenomenon occurs or what its true purpose might be. When you sleep, your brain cycles through different stages, and during the rapid eye movement phase known as REM sleep, your visual cortex activates intensely while your prefrontal cortex, the region responsible for logic and critical thinking, becomes significantly quieter, which explains why dreams feel so bizarre and emotionally charged, yet often make no logical sense whatsoever. During these REM periods, your brain appears to be consolidating memories, processing emotions, and rehearsing responses to threats and challenges. Yet neuroscientists remain uncertain whether dreams themselves are merely a byproduct of this neural maintenance work, or whether the dream experience itself serves an essential function that we have not yet discovered. Some researchers suggest that dreaming allows your brain to sort through the vast amount of information collected during waking hours, filing away important memories while discarding irrelevant details, while others propose that dreams serve a psychological function, helping you process trauma, work through anxieties, and rehearse social situations in a safe environment where consequences do not exist. What makes this phenomenon genuinely mysterious is that we have normalized the experience so completely that we rarely stop to consider how strange it truly is. That every single human being, and indeed most mammals, regularly enters an altered state of consciousness where they experience elaborate hallucinations that feel absolutely convincing in the moment, yet we accept this as simply part of being alive. Asking few serious questions about why evolution would preserve such an energy-intensive process if it were not fundamentally important to our survival and well-being. Imagine a particle existing in two places at once, or spinning both clockwise and counterclockwise simultaneously, until the precise moment you decide to observe it, at which point it collapses into a single definable state as if it had always been there. This is the essence of quantum superposition, one of the most perplexing phenomena in modern physics that defies our everyday intuition about how reality should function. In laboratory experiments conducted repeatedly across decades, physicists have observed that subatomic particles like electrons and photons genuinely exist in multiple states at once, not merely because we lack the tools to measure them properly, but because they fundamentally embody all possible outcomes in a probabilistic cloud until measurement forces them to choose. The famous thought experiment of Schrödinger's cat crystallizes this bewildering concept by imagining a sealed box containing both a living and dead cat, existing in superposition until someone opens the box and collapses the probability wave into a single observable reality. What makes this truly unsettling is that this is not a limitation of our understanding or a gap in our knowledge that will eventually be filled by better instruments. Rather, it appears to be woven into the deepest fabric of existence itself, suggesting that reality operates on principles fundamentally different from the solid, definite world we perceive. Yet despite its profound strangeness, and the fact that Einstein himself called it spooky action at a distance, we have largely normalized quantum superposition into our scientific framework, accepting it as simply how nature works at scales invisible to human perception. This acceptance coexists uneasily with our intuitive sense that things must be one way or another, that a coin must be either heads or tails, that a particle must be here or there, not both simultaneously in some ghostly liminal state. The persistence of this paradox remains one of the deepest mysteries in physics, a glitch in reality that continues to perplex even those who work with its equations every day. Consider the simple fact that you remember yesterday but not tomorrow, that you can influence the future but not the past, that eggs break but do not unbreak, that tea cools but does not spontaneously warm itself in a sealed cup. We experience time as an arrow pointing relentlessly forward, a unidirectional flow from past through present into future, and this asymmetry feels absolute and fundamental to existence itself. Yet when physicists examine the equations that govern the universe at its most basic level, from Newton's laws to Einstein's relativity to quantum mechanics, they discover something profoundly unsettling. These equations are almost entirely time-symmetric, meaning they work equally well whether time flows forward or backward, suggesting that at the deepest level of physical law, there is no arrow, no preferred direction, no reason whatsoever that the future should be fundamentally different from the past. This contradiction sits at the heart of modern science like an unresolved wound, a gap between what we observe and what the laws should permit, and no one truly understands how to reconcile it. The traditional answer points to entropy, to the second law of thermodynamics stating that disorder increases in closed systems, that the universe tends toward chaos and equilibrium. Yet even this explanation contains circular reasoning because entropy itself is defined using time's direction, making the explanation somewhat circular in its logic. We have learned to live with this mystery by simply accepting that somehow, somewhere, time acquired its arrow during the Big Bang or through some mechanism we have not yet discovered, and we move forward through our lives never questioning why we cannot remember futures, or why causation flows only one direction when nothing in fundamental physics demands it should be so. The arrow of time remains one of the deepest unresolved puzzles in science, hiding in plain sight within every moment of our existence, and we persist in our ignorance of its origin despite centuries of scientific inquiry. Picture this moment of waking in absolute darkness, your consciousness suddenly snapping into awareness while your body remains completely frozen, locked in place as though restrained by invisible chains, unable to move a single muscle despite your desperate mental commands to your limbs to respond. And this terrifying immobility typically lasts anywhere from a few seconds to several agonizing minutes that feel like an eternity. During these episodes, people often report an overwhelming sense of dread, a crushing pressure upon their chest, and sometimes the unmistakable sensation of a malevolent presence in the room, a shadowy figure standing at the foot of the bed or looming in the corner, watching silently, which creates an almost unbearable psychological experience where the mind is fully awake, but the body is completely abandoned to paralysis. The scientific explanation for this phenomenon traces back to a natural biological process called REM, or rapid eye movement sleep, which is the stage where dreams occur most vividly, and where the brain essentially paralyses the voluntary muscles to prevent the sleeping body from acting out dreams and potentially harming itself or others in the darkness. Normally, this muscle atonia ends precisely when we transition from REM sleep to wakefulness, but occasionally a glitch occurs in this neural timing, a misalignment between consciousness and motor control, leaving the mind awake while the body remains locked in that dream state paralysis, creating a jarring discord between intention and ability. Consider the vastness of our universe for a moment, where billions upon billions of galaxies stretch across incomprehensible distances, each containing hundreds of billions of stars, and where modern astronomy has confirmed that planets orbit nearly every star we observe. Yet when we turn our most sensitive listening devices toward the cosmos and await a signal from intelligent civilizations, we encounter only silence. An absolute and deafening silence that has persisted for decades despite our technological capacity to detect radio transmissions from remarkably distant sources, and this contradiction between statistical probability and observable reality forms what physicist Enrico Fermi famously articulated as a single penetrating question: where is everybody? The mathematics seem undeniable, for if even a minuscule fraction of stars host planets capable of supporting life, and if even a vanishingly small percentage of those worlds develop intelligent civilizations, then the galaxy should theoretically teem with intelligent species, some of which should be far older and more technologically advanced than humanity, yet the great silence persists as perhaps the most haunting puzzle in science. Where the absence of evidence has become evidence of something profoundly unsettling. The psychological mechanism underlying this paradox operates through a peculiar cognitive dissonance we experience when confronted with the collision between mathematical inevitability and empirical observation. For we possess the intellectual frameworks to calculate that life should exist elsewhere, yet we possess no concrete proof of its existence, creating a persistent tension between what logic demands and what reality delivers. A tension that grows more acute with each passing year of technological advancement and continued silence. Imagine standing in a completely dark room with a single door, and you're told that behind that door exists a particle that is simultaneously in all possible locations until the exact moment you open the door and observe it, at which point it materializes into a single definite position, as if the act of looking at something forces reality itself to make a decision about where that thing actually is. This is the essence of wave function collapse, one of the most perplexing phenomena in quantum mechanics, where particles exist in what physicists call a superposition of all possible states until measurement forces them into one concrete reality. Before you measure an electron, it genuinely exists as a probability cloud, a mathematical wave function describing every place it could possibly be, every spin it could possibly have, every energy it could possibly possess. Yet the moment your instrument touches it or light bounces off it to reach your eyes, the wave function collapses instantaneously into a single, definite state. The psychological mechanism that allows us to accept this peculiar reality stems from our deep discomfort with uncertainty and our evolutionary need to believe that the world has fixed properties independent of our observation. Yet quantum mechanics insists that observation literally creates reality rather than merely revealing pre-existing facts. We have normalized this impossible concept by compartmentalizing it into the realm of the impossibly small, telling ourselves that wave collapse only matters for electrons and photons and not for everyday objects, as though the rules of existence magically change based on scale. Yet this explanation fails under scrutiny because no one can definitively explain where the boundary lies between the quantum realm where collapse occurs and the classical realm where it supposedly does not, nor can anyone explain the mechanism by which conscious observation or measurement could instantaneously affect particles across vast distances, which Einstein famously called spooky action at a distance. Consider a patient suffering from chronic pain who receives a prescription from a trusted physician, takes the pill as directed, and within hours or days experiences genuine relief from their symptoms, only to later discover that the pill contained no active medication whatsoever, merely an inert substance designed to look identical to a real drug. This phenomenon, replicated thousands of times across rigorous clinical studies, represents one of the most profound mysteries at the intersection of mind and body, where the simple belief that one has received treatment produces measurable, physiological changes in the human organism. Brain imaging studies have shown that when people take placebos believing they are receiving pain medication, their brains release actual endorphins, the body's natural painkillers, and neural activity patterns shift in ways indistinguishable from those produced by genuine pharmaceutical intervention. The placebo effect operates through a complex cascade of neurological and biochemical mechanisms, beginning with expectation, which triggers the release of neurotransmitters and activates specific brain regions associated with reward, attention, and emotional regulation, ultimately producing real symptoms of relief, healing, and improvement in conditions ranging from pain and nausea to Parkinson's disease and depression. What remains profoundly difficult to reconcile is that this effect persists even when patients are fully informed they are receiving a placebo with no active ingredients, suggesting that the mere ritual of treatment, the appearance of medical authority, the color and shape of pills, and the simple act of receiving intentional care from another human being can override what we understand about how medicine and biology should function. Witnesses across centuries and continents have reported seeing what appears to be a glowing, spherical object of light materializing during thunderstorms, hovering silently through the air with an apparent intelligence and purpose that defies our understanding of electrical phenomena. These luminous orbs, ranging from the size of a marble to several feet in diameter, emit a soft yet intensely bright glow in colors of yellow, orange, red, or occasionally white, and they seem to drift through the atmosphere with deliberate slowness before vanishing without explanation, sometimes producing explosive sounds or leaving behind the smell of sulfur and ozone. Observers describe moments of profound strangeness when these objects pass through walls, enter homes through closed windows, travel alongside vehicles on highways, or hover just above the ground before dissipating entirely, leaving no trace of their existence except in the memories and testimonies of those who witnessed them. Scientists have proposed numerous theories to explain ball lightning, ranging from plasma formations and luminous phenomena created by energy discharge, to ionized air and exotic chemical reactions. Yet none of these explanations have achieved consensus or successfully replicated the phenomenon in controlled laboratory conditions with consistency. The mystery persists because ball lightning exists in a peculiar space where documented sightings are numerous enough to be undeniably real. Yet the phenomenon itself remains impossible to capture, measure, or reproduce on demand, creating a situation where we must accept the testimony of thousands of credible witnesses while simultaneously acknowledging that our most advanced instruments and theories cannot adequately account for what they observed. We continue to theorize and investigate, yet ball lightning remains one of the most elusive and perplexing atmospheric mysteries, a reminder that even within the realm of electrical and meteorological science, nature still possesses secrets that elude our understanding. Imagine a world where the boundaries between your senses have dissolved into one another, where listening to a violin concerto floods your mind with cascading shades of deep purple and crimson, where the number 3 always appears wrapped in a golden hue, or where the taste of cinnamon inevitably triggers the sensation of touching rough burlap against your skin. This is the everyday reality for millions of people who experience synesthesia, a peculiar neurological condition in which stimulation of one sensory pathway leads to automatic and involuntary experiences in another sensory modality. For those with grapheme color synesthesia, each letter and number possesses its own distinct color that cannot be changed or ignored, a phenomenon so consistent that a person with this trait will always see the letter A as red, the number 7 as silver, or the letter M as deep blue every single time they encounter it. For others with auditory visual synesthesia, every sound they hear produces corresponding visual experiences, whether it is music painting abstract shapes across their vision or simple speech triggering cascades of color and light that seem to bloom in the air around them. The mechanisms underlying synesthesia remain deeply mysterious to contemporary neuroscience, though researchers have discovered that it appears to involve unusual patterns of neural connectivity, possibly caused by differences in how connections form during brain development or how neural pruning operates in early childhood. The brains of synesthetes show atypical cross-activation between sensory regions that typically remain separate in non-synesthetic individuals, suggesting that their sensory boundaries are quite literally wired differently. Yet, despite decades of scientific investigation, we still cannot fully explain why these neural differences exist, how they persist across a lifetime without degradation or adaptation, or why they seem to affect certain populations more than others. On the evening of August 15, 1977, a radio telescope facility in Delaware began recording signals from the cosmos, and what they captured would become one of the most tantalizing mysteries in the history of astronomical observation. A volunteer astronomer named Jerry Amon was reviewing the computer printout from the Big Ear radio telescope when he noticed something extraordinary, a pattern of letters and numbers that indicated a signal of unusual strength coming from a specific region of space near the Chi Sagittarii star group. The signal was so remarkable that Amon circled it on the paper and wrote the word "wow" in the margin, a reaction that would define the incident for decades to come. The signal lasted 72 seconds, which was precisely the length of time it took for the rotating telescope to sweep past that particular area of the sky, and it displayed characteristics that suggested an intelligent, artificial origin rather than any known natural cosmic phenomenon. The signal's strength exceeded the background noise significantly. It came from a narrow bandwidth rather than broadcasting across a wide spectrum, and its frequency of 1400 MHz was suspiciously close to the universal hydrogen line, a frequency that scientists had theorized might be used for interstellar communication. What makes this incident so profoundly strange is that despite numerous attempts to relocate the signal in subsequent observations, it has never been detected again, not in the following decades of careful monitoring by astronomers worldwide. The psychological impact of the WOW signal stems from how it occupies the peculiar space between extraordinary evidence and complete absence of reproducibility, creating a kind of suspended disbelief that has persisted for nearly 50 years. We are drawn to the signal because it represents the tantalizing possibility of contact, the confirmation that we are not alone, yet the total failure to detect it again forces us into an uncomfortable limbo where we can neither dismiss it nor embrace it fully as genuine. Imagine a particle approaching a barrier that, by all conventional logic and classical physics, should be absolutely impossible for it to cross, yet somehow, inexplicably, it passes right through as if the barrier were merely a suggestion rather than a fundamental wall of reality. This phenomenon, known as quantum tunneling, represents one of the most profoundly disorienting glitches in our understanding of how the universe operates at its most fundamental levels. Particles such as electrons and photons routinely demonstrate the ability to traverse energy barriers that should definitively prevent their passage, appearing on the opposite side of obstacles without ever having climbed over them or gone around them, as if the solid nature of matter itself were negotiable under certain mysterious conditions. Scientists observe this behavior consistently in laboratories, measuring it, quantifying it, and building entire technologies around its predictable occurrence, from tunnel diodes to radioactive decay to the very mechanisms that power nuclear fusion in stars. The psychological mechanism that allows us to accept this conceptual impossibility rests primarily on our compartmentalization of quantum mechanics as belonging to a fundamentally different realm of physics than the everyday world we navigate. We have constructed elaborate mathematical frameworks that describe quantum tunneling with astonishing precision, allowing us to predict exactly how often particles will tunnel through barriers of specific heights and thicknesses, which creates an illusion of understanding even though the equations themselves contain no explanation for why this occurs at all. The mathematical description functions perfectly without requiring us to answer the deeper question of mechanism, and so we have normalized this deeply irrational phenomenon by dressing it in the language of probability distributions and wave functions, transforming the genuinely unexplainable into something that merely sounds technical and therefore acceptable. In the beginning of our universe, according to our best understanding of physics, matter and antimatter should have been created in perfectly equal quantities during the Big Bang, emerging from the same primordial quantum fluctuations with the same probability and force. When matter and antimatter particles encounter one another, they annihilate in a violent release of pure energy, converting their mass entirely into radiation according to Einstein's elegant equation. This means that if equal amounts of matter and antimatter had truly existed at the universe's birth, they would have completely obliterated each other in the first fractions of a second, leaving behind only a featureless sea of photons and fundamental particles with no structure, no atoms, no stars, and no possibility for galaxies or life to ever emerge. And yet here we are, in a universe that is almost entirely made of matter, with antimatter being vanishingly rare, confined to brief laboratory creations and distant cosmic events. Scientists have searched for decades to understand this profound asymmetry, knowing that some mechanism in the earliest moments after the Big Bang must have somehow tilted the scales in favor of matter, allowing slightly more matter to exist than antimatter, giving the universe permission to become what we observe today. The leading theories invoke exotic physics at temperatures and energies far beyond our ability to recreate, invoking hypothetical particles and processes governed by symmetry violations that seem to require nature to behave differently for matter than for antimatter in ways we cannot yet detect. Despite our considerable progress in understanding particle physics and the universe's history, despite our sophisticated experiments and mathematical frameworks, we still cannot explain why the universe chose this path, why matter won this cosmic lottery, or whether the asymmetry emerged from some unknown interaction we have yet to discover or some principle of physics that fundamentally breaks the symmetry between particles and their antiparticles in a way we have not yet comprehended. When a star collapses at the end of its life and forms a black hole, it creates one of the most profound mysteries in modern physics, a contradiction so fundamental that it challenges our understanding of how reality itself operates. A black hole is a region in space where gravity has become so extraordinarily intense that nothing, not even light, can escape once it crosses the event horizon, the point of no return. According to Einstein's general relativity, which has been validated countless times, all the matter that falls into a black hole is compressed into an infinitely dense point called a singularity, and in doing so, all information about that matter appears to vanish forever from the observable universe. This poses the information paradox, a problem that has haunted theoretical physics since Stephen Hawking discovered in 1974 that black holes are not entirely black, but instead slowly evaporate through a process now called Hawking radiation. If black holes emit radiation and eventually evaporate completely, then all the information about everything that ever fell into them would be destroyed, which violates a fundamental principle of quantum mechanics stating that information cannot be created or destroyed, only transformed. The psychological discomfort this creates stems from the collision between two pillars of modern physics that should not contradict each other, and yet they do. For decades, physicists have proposed solutions ranging from the idea that information is somehow preserved in subtle correlations within the radiation, to the notion that black holes leave behind tiny remnants containing all the lost information, to more exotic ideas involving parallel universes and holographic principles. What remains extraordinary is that despite possessing some of the most advanced mathematical frameworks and observational tools humanity has ever developed, We still cannot definitively resolve this paradox, and no experimental test has yet provided a clear answer. Imagine sitting across from someone having a conversation, watching their lips move as they speak, and hearing them say one sound, yet when you close your eyes and listen without watching their face, your brain tells you they said something completely different. This is the McGurk effect, a fascinating neurological phenomenon discovered in 1976 by psychologist Harry McGurk, and it reveals something profoundly unsettling about the nature of human perception itself. In the classic demonstration, a person on video is seen mouthing the syllable ga ga ga, while an audio track plays the sound ba ba ba, and the overwhelming majority of observers report hearing d d d instead, a third sound that exists nowhere in the original stimulus. When the same audio plays without the video, listeners correctly identify it as ba ba ba, but the moment the visual information enters the equation, the brain performs an involuntary act of synthesis, combining what the eyes see with what the ears hear into something entirely new. This occurs not because of conscious reasoning or intentional misperception, but because the brain treats visual and auditory information as equally valid sources of truth, integrating them into a unified sensory experience before conscious awareness even processes what has happened. The mechanism underlying this phenomenon points to how deeply our perception is constructed rather than simply received, revealing that what we believe we are experiencing in real time is actually an elaborate interpretation orchestrated by neural systems operating beneath the threshold of awareness. Our brains have evolved to prioritize visual information when it comes to speech perception, because lip reading provided crucial survival advantages in noisy environments and complex social hierarchies. And this ancient prioritization remains embedded in our neurology despite the technological world we now inhabit. Imagine waking up after surgery, your leg or arm completely removed, and yet you can still feel it there, as vividly as if it were still attached to your body. You might feel an itch on fingers that no longer exist, or experience sharp pain shooting through a foot you no longer possess. This is the phenomenon known as phantom limb, and it affects the vast majority of people who have undergone amputation. Yet science struggles to fully explain why our brains insist on maintaining the presence of body parts that are objectively and undeniably gone. Patients report sensations so realistic that they sometimes forget momentarily and attempt to stand on a missing leg, or reach for something with a phantom hand, only to experience the disorienting crash of physical reality when they remember the limb is no longer there. The sensations vary widely from person to person. Some feel itching or tingling, others experience burning pain or the sensation of the limb being in an uncomfortable position. The phantom sensations can persist for years or even decades after the amputation, sometimes fading with time, sometimes remaining as vivid as ever. What makes this phenomenon so peculiar is that our current understanding of neuroscience suggests the brain is essentially hallucinating, creating sensory experiences from neural pathways that no longer receive input from actual limbs. Yet this explanation feels insufficient when confronted with the lived reality of these patients. The prevailing theory involves the body's sensory map in the brain, the so-called homunculus, which is believed to maintain its neural representation of missing limbs even after they are physically gone, continuing to fire signals as if the body part still exists. Yet despite our acceptance of this neurological explanation, we have not truly solved the deeper mystery of why consciousness insists on perceiving something that cannot possibly be there, and why our brains refuse to update their internal model of our bodies even when presented with overwhelming evidence of loss. Consider the fundamental question that sits at the very foundation of our existence. How did life begin on this planet, and what mechanism transformed non-living chemical compounds into the first living organisms capable of reproduction and adaptation? Despite centuries of scientific inquiry, despite the brilliant minds of biochemists and molecular biologists working in laboratories across the world, we remain profoundly uncertain about this threshold moment when chemistry became biology. We understand the components involved, the amino acids and nucleotides that compose all known life, and we have conducted countless experiments attempting to recreate the conditions of early Earth. Yet the precise sequence of events that sparked the transition from inert matter to living systems remains shrouded in mystery. The problem extends deeper than simple ignorance, for even the most sophisticated theories present us with an enormous logical gap that demands explanation. How could the spontaneous arrangement of molecules achieve the extraordinary complexity required for self-replication without some mechanism already in place to guide that assembly? We have normalized this uncertainty by treating it as merely another unsolved scientific problem awaiting future discovery, compartmentalizing our awareness of how utterly strange it is that we cannot explain the very phenomenon that makes all other explanation possible. Yet when we truly examine this gap, we confront something that challenges our understanding of how order and complexity emerge from randomness and chemistry. Life appears to possess properties that seem almost to transcend their chemical basis, an organizational sophistication that our current frameworks struggle to account for, and we proceed through our academic discussions and laboratory experiments as if this inexplicable transition is simply waiting for incremental knowledge to fill the void, rather than acknowledging the profound conceptual mystery at the heart of our existence. Consider the moment you glance at a cloud and suddenly see the unmistakable shape of a face staring back at you, or you notice what appears to be a figure watching from the shadows of your bedroom wall, or perhaps you catch the haunting expression of a human face in the texture of tree bark or the arrangement of craters on the moon's surface. This phenomenon, which occurs countless times throughout our daily lives without us even recognizing it, is called pareidolia, and it represents one of the most pervasive yet poorly understood glitches in how our brains process visual information. What makes pareidolia particularly fascinating is that it is not a malfunction of our vision itself, but rather an overzealous tendency of our pattern recognition systems to find meaning and familiar shapes in random or ambiguous visual stimuli. Our brains have evolved over millions of years to detect faces and figures in our environment because doing so, even if sometimes incorrectly, provided a survival advantage to our ancestors. A person who could quickly spot a predator lurking in tall grass, even if they occasionally mistook a shadow for a threat, would live longer than someone who required absolute certainty before reacting. This neural mechanism became so deeply ingrained in our consciousness that it persists today with remarkable stubbornness, firing up our pattern recognition systems at the mere suggestion of eyes, nose, or mouth arranged in even the vaguest approximation of a face. What is truly perplexing is that we continue to experience pareidolia even when we are fully aware of what is happening, even after we intellectually understand that there is no actual face in that cloud or on that wall. We cannot simply turn off this response through conscious will or reasoning, which suggests that pareidolia operates at a level of neural processing that exists somewhat beyond our direct control, a glitch so fundamental to our visual perception that it has become inseparable from how we see the world itself. Imagine two particles that were once connected, now separated by vast distances, perhaps on opposite sides of the universe, and yet when you measure a property of one particle, the other instantly responds as if receiving an invisible signal, a phenomenon that Einstein himself called spooky action at a distance, because it seemed to violate everything we understood about how reality should function. This is quantum entanglement, one of the most verified yet deeply unsettling discoveries in modern physics, where particles become correlated in such a way that measuring one instantaneously influences the state of the other, regardless of the space between them, and this has been demonstrated thousands of times in laboratories across the world with increasing precision and certainty. The mechanism behind this apparent violation of locality stems from the probabilistic nature of quantum mechanics itself, where particles do not possess definite properties until they are observed or measured, existing instead in a superposition of all possible states simultaneously. And when two particles become entangled, their quantum states become mathematically linked in such a way that observing one collapses both into correlated outcomes. What makes this phenomenon so profoundly strange is that it does not allow faster-than-light communication, yet it does seem to suggest that the universe is fundamentally non-local, that distant objects can influence each other instantaneously through mechanisms we still do not fully comprehend, defying our intuitive sense that nothing can travel faster than light or act without some mediating force between them. Imagine filling two identical containers with water, one at room temperature and one heated to near boiling point, then placing both into a freezer at the same moment and watching as the hot water freezes first, defying every principle of thermal physics that we believe we understand. This phenomenon, known as the Mpemba effect, named after Erasto Mpemba, a Tanzanian student who observed it in the 1960s, represents one of the most perplexing anomalies in the natural world, a glitch in reality that challenges our fundamental understanding of heat transfer and thermodynamic principles. The effect suggests that under specific conditions, hot water can transition to a solid state faster than cold water, a discovery that has confounded physicists for decades and remains incompletely explained despite numerous investigations and peer-reviewed studies attempting to unravel its mysteries. When researchers began examining this effect more closely, they discovered that the mechanism behind it likely involves several competing factors working simultaneously in ways that we still struggle to fully comprehend or quantify. The leading theories propose that convection currents in hot water may distribute the cooling more evenly throughout the liquid, that dissolved gases escape more readily from heated water and therefore reduce the amount of substance that must be cooled, that hydrogen bonding structures in water change fundamentally when heated, and that the container itself may conduct heat differently depending on the initial temperature difference. Yet none of these explanations entirely accounts for every observed instance of the effect. What makes the Mpemba effect particularly unsettling is that it exists in a space between the known and unknown, a phenomenon that is reproducible and real yet remains stubbornly resistant to unified theoretical explanation, suggesting that our models of thermodynamics, while generally reliable and tested across countless applications, might be incomplete or context-dependent in ways we have not yet fully appreciated or acknowledged. In October of 2017, astronomers detected something unprecedented in our solar system, an object moving with such unusual velocity and trajectory that it could only have originated from beyond our cosmic neighborhood, arriving from interstellar space itself. Named Oumuamua, which means a messenger from afar arriving first in Hawaiian, this celestial visitor presented dimensions roughly 400 meters in length, but only 40 meters in width, making it extraordinarily elongated and unusual in shape, more akin to a cosmic cigar or needle than the spherical asteroids we typically observe. What makes Oumuamua truly perplexing is that its trajectory and acceleration patterns do not conform to the gravitational influences we can measure from known celestial bodies, suggesting either an unknown propulsion mechanism, invisible matter surrounding it, or something entirely outside our current understanding of physics. The object traveled through our solar system at speeds too great to be captured by our gravity, yet its path showed subtle deviations that astronomers cannot adequately explain through conventional means. Some scientists have cautiously proposed the possibility that Oumuamua might be an artificial probe, perhaps a solar sail constructed by an advanced extraterrestrial civilization, deliberately sent across the vast distances between stars, though such speculation remains highly controversial and largely rejected by mainstream science. The deeper mystery lies in the profound uncertainty that persists even after intense study, the recognition that we observed something genuinely anomalous passing through our cosmic backyard and departed without us truly understanding its origin, composition, or purpose, leaving us with more questions than answers as we contemplate whether we witnessed nature's eccentricity or something far more intentional and distant drifting silently through the darkness of space. Every single night, billions of humans around the world surrender their consciousness to an involuntary state of unconsciousness, lying vulnerable and immobile for roughly 8 hours, during which time they experience vivid hallucinations we call dreams, while their bodies undergo mysterious biological processes that science still struggles to fully comprehend or explain. We know that sleep is essential for survival, that animals deprived of it will eventually die, yet the precise mechanisms that govern why our brains shut down this way remain frustratingly elusive despite centuries of scientific inquiry. Our bodies seem designed by some unknown logic to require this extended period of darkness and sensory deprivation, forcing us into a state where we cannot respond to threats, cannot work, cannot engage with the world, and yet evolution has apparently deemed this vulnerability so necessary that it has been preserved across every known species on Earth. The leading theories suggest that sleep allows our brains to consolidate memories, to flush out metabolic toxins accumulated during waking hours, to repair cellular damage, and to restore energy supplies. Yet none of these explanations fully accounts for the phenomenon, and each theory leaves gaps and inconsistencies that researchers struggle to resolve. What remains genuinely unsettling is that we spend approximately one-third of our entire lives in this state, completely surrendering control, entirely dependent on our internal systems to maintain basic bodily functions while our consciousness retreats into a realm of its own making. And we have simply accepted this as normal rather than questioning how profoundly strange it truly is that we must regularly become dead-like, unresponsive, and temporarily unreachable in order to remain alive and functional. There exists a peculiar threshold in human perception where something appears almost human but not quite, and at that precise moment, instead of drawing us closer, it repels us entirely. When you encounter a humanoid robot with perfectly sculpted features and lifelike skin, or a computer-generated character animated with meticulous detail, yet still somehow wrong, a strange sensation creeps through your consciousness, a discomfort that feels disproportionate to what you're actually observing. This is the uncanny valley, a psychological phenomenon where entities that are nearly but not quite human trigger profound unease rather than acceptance or affection. The closer something becomes to human appearance without achieving complete authenticity, the more our brains seem to reject it, generating feelings of revulsion or dread that bear no logical relationship to the object itself. A cartoon character with exaggerated features causes no distress, and a perfectly human person causes none either, yet that intermediate space, where we recognize humanity without quite believing in it, becomes a zone of inexplicable psychological discord. Scientists theorize this stems from our evolutionary need to quickly identify whether something before us is genuinely human or a threat, a corpse, or something fundamentally wrong. Our brains became finely tuned to detect minute inconsistencies in human behavior and appearance, and when those signals conflict, when the eyes move correctly but the smile doesn't quite reach them, when the proportions are nearly right but the texture is subtly off, our ancient warning systems activate. Yet despite decades of research and our rational understanding of why this happens, the discomfort persists unchanged when we encounter these near-human forms. We understand the mechanism, we can explain it, we know intellectually that nothing is actually wrong, and still we feel that creeping wrongness deep in our bones. The uncanny valley remains, waiting in every hyperrealistic digital face and android prototype, reminding us that some aspects of our perception operate beyond the reach of understanding or reason. In the year 2015, astronomers observing a distant star designated KIC 8462846, now commonly known as Tabby's star, noticed something deeply peculiar in the data streams coming back from the Kepler Space Telescope, patterns of dimming that seemed to defy conventional explanation, and suggested that something massive was obscuring the star's light in ways that no known celestial body should be able to produce. The star, located approximately 1,480 light-years away in the constellation Cygnus, began exhibiting irregular and unpredictable dips in brightness, sometimes fading by as much as 20% in only a matter of days, an anomaly so significant that it immediately captured the attention of the scientific community and sparked wild speculation about what could possibly be causing such dramatic fluctuations. Traditional explanations like planetary transits, which occur when planets pass in front of their host stars and create predictable patterns of dimming, simply did not account for the erratic nature of these observations, and the variations were far too substantial to be explained by any known astronomical phenomena that astronomers had previously encountered. Some researchers began to entertain the hypothesis that an advanced extraterrestrial civilization might have constructed a megastructure around the star, perhaps a Dyson sphere designed to harness its energy, and while this captured public imagination and made headlines around the world, it remained pure speculation without concrete evidence. The psychological mechanism driving our fascination with Tabby's star appears to rooted in the fundamental human tendency to interpret unexplained phenomena as evidence of something extraordinary or intentional, particularly when that phenomenon exists in the vastness of space, where our understanding remains limited and incomplete. Deep within the cosmos, astronomers have discovered something that should not exist, a mathematical contradiction so fundamental that it calls into question our understanding of the universe itself, and this contradiction is known as the Hubble tension. The Hubble constant is a number that represents how fast the universe is expanding, a value that should be consistent whether we measure it using ancient light from the distant past or by observing nearby galaxies in our cosmic neighborhood. Yet when scientists perform these measurements using different methods, they arrive at different answers, and the discrepancy is large enough that it cannot be dismissed as simple measurement error or instrumental uncertainty. One method involves observing the cosmic microwave background radiation, the oldest light in the universe that has been traveling toward us for nearly 14 billion years. And from this ancient light, physicists calculate how quickly space itself must be stretching, predicting a Hubble constant of approximately 67 kilometers per second per megaparsec. Another method involves measuring distances to nearby supernovae and galaxies using a cosmic distance ladder, a technique that builds upon established measurements step by step, and this more direct approach yields a value closer to 73 kilometers per second per megaparsec, a difference that seems small in numbers but represents a fundamental inconsistency in our cosmological model. The psychological mechanism at work here is one of denial and compartmentalization, for scientists continue to use both measurements in their research despite knowing they cannot both be correct, treating this contradiction as an anomaly that will eventually resolve itself rather than as evidence that something fundamental may be missing from our theories. Consider the remarkable phenomenon of animal magnetoreception, wherein countless species across the globe possess an inexplicable ability to detect and navigate using the Earth's magnetic field, a navigational sense so precise, and yet so fundamentally invisible to human perception that we remain unable to fully understand its mechanisms despite decades of intensive scientific investigation. Migratory birds travel thousands of miles each year, crossing entire continents and oceans with an accuracy that defies explanation, following magnetic pathways that exist only as theoretical constructs in our minds, and they accomplish this feat without instruments, without maps, without any technology whatsoever. Yet they arrive at their destinations with such consistency that their journeys seem almost predetermined by some invisible cosmic force. Sea turtles hatch on beaches and immediately orient themselves toward the ocean by sensing magnetic gradients so subtle that our most sensitive laboratory equipment struggles to measure them, while monarch butterflies, creatures whose individual lifespans span mere months, somehow inherit magnetic navigation instructions encoded within their genetics, allowing them to find their way to specific forests in Mexico that they themselves have never visited in any previous lifetime. Sharks and rays possess specialized organs called ampullae of Lorenzini that detect electromagnetic fields generated by muscle contractions in their prey. Yet the exact mechanism by which these organs translate magnetic sensation into directional information remains largely mysterious. The conventional explanation suggests that magnetite crystals or flavin-based molecules in neural tissues might serve as biological compasses, yet when researchers examine these proposed mechanisms in detail, the physics simply does not align perfectly with observed behavior. Animals navigate with an accuracy that theoretical models cannot fully predict, responding to magnetic fluctuations and anomalies in ways that seem to exceed what their supposed sensory apparatus should allow. Imagine two particles that were once connected, now separated by vast distances, perhaps on opposite sides of the universe, yet they remain mysteriously linked in a way that defies everything we understand about space and causality. When you measure a property of one particle, its distant twin instantaneously responds and aligns with that measurement, as though some invisible signal traveled between them faster than light itself, which according to Einstein's theory of relativity should be impossible. This phenomenon is called quantum entanglement or quantum nonlocality, and it represents one of the deepest puzzles in modern physics that continues to perplex scientists and philosophers alike. The mechanics work like this. In the quantum realm, particles exist in what physicists call a superposition, meaning they hold multiple states simultaneously until observed, and when two particles become entangled through their initial interaction, their fates become forever bound together in a mathematical correlation that has no classical explanation. The moment one particle's wave function collapses into a definite state through measurement, the other particle's wave function appears to collapse instantaneously into a corresponding state, regardless of the distance separating them, suggesting some form of instantaneous connection that transcends space itself. What makes this even more bewildering is that no usable information can actually be transmitted this way, so it does not violate relativity, yet the correlation itself seems to travel at infinite speed, creating a logical paradox that sits at the very heart of quantum mechanics. We have normalized this glitch in reality by accepting it as part of the quantum framework, conducting countless experiments that consistently confirm these non-local correlations exist, testing Bell's inequalities, and discovering violations that prove the phenomenon is real rather than some hidden variable we have simply not yet discovered. Imagine lying in bed at the threshold between wakefulness and sleep, when suddenly your mind experiences what feels like an enormous explosion happening inside your skull, a deafening bang or crack that jolts you awake with your heart racing and adrenaline flooding through your body. Yet when you look around your darkened bedroom, there is nothing. No sound has actually occurred in the physical world, no flash of light, no tremor or disturbance. Only the reverberating echo of something that existed entirely within the confines of your own consciousness. This is exploding head syndrome, a parasomnia that affects a small but significant population of people, primarily occurring during the transition phases of sleep, when the brain is neither fully awake nor fully asleep, but suspended in that liminal space where the boundaries between internal sensation and external reality become dangerously blurred. The experience is profoundly disorienting because the sensory input feels absolutely real, the loudness is overwhelming, the sense of impact is undeniable, yet no objective evidence of the event exists outside the sufferer's mind. The mechanism appears to involve a temporal disconnection between the auditory processing centers of the brain and the motor systems that typically shut down during sleep, creating a situation where the brain generates the full sensory experience of an explosion or violent noise without the body's usual filtering mechanisms being fully engaged, essentially allowing an isolated neural firing pattern to surge through consciousness with the full weight and legitimacy of genuine sensory input. The syndrome carries an ironic name because despite the terrifying nature of the experience, the condition is not dangerous and causes no actual harm to the brain or skull. Yet the psychological impact can be substantial because sufferers often find themselves trapped in a cycle of anxiety about the next occurrence, sometimes developing a kind of anticipatory dread that makes falling asleep increasingly difficult and stressful. Somewhere in the depths of space, roughly every few seconds, an invisible burst of radio energy arrives at Earth, carrying immense power compressed into just milliseconds of time, and we have almost no idea where it comes from or what produces it. These events are called fast radio bursts, and they represent one of the most perplexing mysteries in modern astronomy because they appear suddenly, last only fractions of a second, and then vanish entirely, leaving behind only the faint electromagnetic whispers that our most sensitive instruments can barely detect. When astronomers first discovered these signals in 2007, they were completely baffled, believing initially that they were merely equipment malfunctions or interference from nearby satellites. Yet as detection methods improved and more bursts were cataloged, the reality became undeniable that something genuinely unusual was occurring across the cosmic void. The bursts release as much energy in a single millisecond as our sun produces in an entire day, an almost incomprehensible amount of power concentrated into a timeframe so brief that it seems to defy our understanding of physics. We can narrow down their general origins to galaxies billions of light years away, yet we cannot determine the exact mechanism that produces them, nor can we predict when or where the next burst will occur, making them seem almost random in their appearance. Various theories have emerged to explain fast radio bursts, ranging from colliding neutron stars and exploding magnetars to suggestions involving exotic phenomena we have not yet discovered, yet each theory struggles to explain all the observed characteristics we have documented. Some bursts appear only once while others repeat from the same location, suggesting different origins or mechanisms, and this variation itself hints at processes we do not yet comprehend. The signals are scattered across frequency ranges that should theoretically disperse them more than we observe, implying something in the space between us and their sources is preventing that expected scattering, or the sources themselves produce signals with unusual properties. On the morning of June 30th, 1908, in a remote region of Siberia near the Tunguska River, something catastrophic occurred that flattened approximately 80 million trees across an area of about 2,000 square kilometers, yet left almost no crater and no significant meteorite fragments for scientists to examine and study. The explosion, estimated to be thousands of times more powerful than the atomic bomb dropped on Hiroshima, occurred in one of the most isolated places on Earth, and had it happened over a populated city, it would have killed millions of people instantly. Yet instead it occurred in an unpopulated wilderness where indigenous peoples lived, and only a handful of witnesses existed to describe what they had seen that fateful morning. The blast was so intense that it flattened trees in a radial pattern pointing away from a central location, creating a distinctive butterfly or bow tie-shaped pattern of destruction that remained visible from aerial photographs decades later. Yet when expeditions finally reached the site years afterward, they found no obvious impact crater, no large meteorite fragments, and no definitive evidence of what had caused this unprecedented explosion. Scientists have proposed numerous explanations over the decades, including a comet explosion, a meteor explosion, a natural nuclear explosion, or even extraterrestrial spacecraft. Yet none of these theories adequately explains all of the physical evidence: the lack of a crater, the absence of significant meteorite material, and the peculiar characteristics of the blast pattern itself. The psychological mechanism at work here involves our deep human need to categorize and explain unusual phenomena within established scientific frameworks. So when an event like Tunguska refuses to fit neatly into existing categories, we experience a kind of cognitive discomfort that compels us to generate increasingly elaborate theories rather than simply accept that we do not yet have a complete understanding. Imagine a moment where the effect arrives before the cause, where the future seems to reach back and influence the past in ways that should be impossible according to everything we understand about the flow of time itself. Retrocausality is precisely this phenomenon, and it appears in the quantum realm with such consistency that physicists have stopped dismissing it as mere measurement error or experimental artifact. In the famous delayed choice quantum eraser experiment, researchers send photons through a double-slit apparatus, and then later decide whether to measure which slit the photon went through, only to discover that this future decision somehow influences how the photon behaved in the past, changing whether it acted as a wave or a particle retroactively. The photon seems to know what choice will be made in the future and adjusts its historical behavior accordingly, as though information flows backward through time as easily as it flows forward. What makes this even more unsettling is that similar patterns appear in other quantum experiments, including those involving entangled particles and in certain interpretations of quantum mechanics, where the observer's future observation seems to determine the state of particles that existed moments before. The psychological mechanism that allows us to live with this contradiction is our compartmentalization of quantum mechanics as something that only applies to the infinitesimally small, something that does not reach into our everyday experience, and therefore something we can accept as true without fundamentally reimagining how causality itself operates. We have normalized retrocausality by treating it as a curiosity of the subatomic world rather than a revelation about the nature of time itself. Yet the implications remain deeply troubling. If the future can reach back and change the past, even in limited quantum contexts, then the very foundation of causality, the bedrock assumption that the past is fixed and determines the future, begins to crumble. Deep within the cosmic void, beyond the reach of our telescopes and the limits of our current understanding, there exists something that astronomers have named the Great Attractor, a mysterious gravitational anomaly that appears to be pulling our entire galaxy, along with millions of others, toward an unseen destination at an incomprehensible velocity of roughly 600 kilometers per second. When scientists first began mapping the movements of galaxies throughout the universe, they noticed something profoundly disturbing. The Milky Way and its neighboring galaxies were not moving randomly through space, as the Big Bang theory might suggest, but instead seemed to be flowing together in a coordinated manner toward a specific region in space, as though drawn by an invisible cosmic hand. This region, located approximately 250 million light-years away in the direction of the Centaurus and Hydra constellations, contains no visible matter that could account for such an enormous gravitational pull, no supermassive black holes, no galaxy clusters dense enough to explain the phenomenon, yet the gravitational influence persists with undeniable force. The psychological weight of this discovery lies in its fundamental challenge to our sense of cosmic order and predictability. We have constructed an entire framework of physics based on understanding gravity through observable mass, yet here exists a gravitational force of almost inconceivable magnitude that pulls on billions of galaxies, including our own, with no identifiable source. Some physicists propose that dark matter, that invisible substance comprising most of the universe's mass, might be concentrated in some enormous structure beyond our observational horizon, while others suggest the Great Attractor might be an illusion created by our particular position within the universe, a perspective bias that makes distant structures appear to pull at us when in fact we are simply observing the universe from a skewed vantage point. Consider the famous experiment where researchers ask participants to watch a video of people passing basketballs between themselves, a task that requires focused attention and counting the number of passes made by one team. And during this simple exercise, a person in a gorilla suit walks directly across the court, pounds their chest, and walks off screen, yet roughly half of all viewers never see the gorilla at all. Their eyes passing directly over it multiple times, while their conscious attention remains locked onto the basketball counting task. A phenomenon so striking and repeatable that it challenges our fundamental assumptions about how we perceive the world around us. This is inattentional blindness, the curious and unsettling glitch in human perception where we are literally incapable of seeing things that exist in plain sight, objects and events occurring within our direct line of sight, but outside the narrow beam of our focused attention, rendering them invisible not because they lack visibility, but because our brains have decided they are not worth processing. The mechanism underlying this phenomenon relates to how our attentional system operates as a bottleneck, a filtering system that cannot process everything simultaneously, so it prioritizes whatever task we have deemed important and essentially mutes sensory input that falls outside this chosen focus. Our consciousness becomes a spotlight that illuminates only what we have decided matters, leaving everything else in practical darkness, despite the fact that light waves are reaching our retinas and being partially processed by our visual cortex. In the autumn of 1991, a cosmic ray detector located at the University of Utah recorded something that should not have existed according to everything physicists understood about the universe. A single subatomic particle that arrived at Earth carrying an energy level so extraordinarily high that the scientist who first analyzed the data reportedly exclaimed the particle's name, which became the "Oh my God" particle in scientific literature. A designation that persists today as a permanent reminder of humanity's astonishment. This particle possessed an energy of approximately 300 billion electron volts, which translates to roughly 50 joules of kinetic energy, an amount so concentrated into a single subatomic object that it exceeded the theoretical maximum energy threshold that cosmic rays should be able to achieve based on the Greisen-Zatseping-Kuzmin limit, a fundamental constraint that had been accepted as law for decades. The mechanism that makes this particle so psychologically and conceptually troubling relates to how we construct our understanding of physical limitations, boundaries that exist not merely as suggestions, but as seemingly absolute rules derived from the interactions between cosmic rays and the cosmic microwave background radiation that permeates all of space. Yet this particle simply ignored those rules entirely, arriving with an energy signature that demanded an explanation that conventional physics could not provide. Since that detection, despite decades of subsequent observations and technological improvements in cosmic ray detection, scientists have never definitively explained where this particle originated or how it accumulated such extraordinary energy, leading to theoretical proposals involving exotic sources like topological defects in spacetime, unknown particle accelerators at cosmic scales, or phenomena we have not yet conceived. Imagine standing in complete darkness, a void so vast and empty that light itself seems to lose meaning, and then being told that this nothingness is not truly empty at all, but rather filled with an invisible force that grows stronger the further you look into the distance. This is the essential paradox of the cosmological constant, one of the most perplexing mysteries that continues to perplex physicists and cosmologists as they peer into the deepest structures of reality itself. In the early 20th century, Albert Einstein introduced this constant into his field equations of general relativity, originally as a mathematical convenience to maintain a static universe that would not collapse under its own gravity. Yet decades later, astronomers discovered through observations of distant supernovae that the universe is not collapsing at all, but rather accelerating outward, expanding faster and faster as time progresses. This acceleration requires an explanation, and the cosmological constant emerged as the leading candidate, suggesting that empty space itself possesses an inherent energy density that pushes galaxies apart with ever-increasing force. The psychological mechanism behind our acceptance of this concept lies in our learned ability to trust mathematical frameworks even when they describe phenomena that defy intuitive understanding. We have become accustomed to accepting equations as truth even when those equations describe something fundamentally invisible and unmeasurable in any direct sense. The cosmological constant represents roughly 70% of all matter and energy in the universe, yet it remains entirely imperceptible to our instruments and senses, existing as pure inference drawn from observational data that requires constant refinement and reinterpretation. You are descending into sleep, your body growing heavier with each breath, your mind beginning to drift away from the conscious world and into the soft darkness of slumber, when suddenly your entire body convulses with a violent, involuntary twitch that jolts you back to wakefulness, your heart racing, your muscles tensed, leaving you confused and disoriented about what has just occurred within your own body. This phenomenon, known as hypnic jerks or sleep starts, represents one of the most universal yet still mysterious interruptions to the sleep process that humans experience, affecting up to 70% of the population at various points in their lives. Yet science has never been able to provide a definitive explanation for why our bodies behave this way as we transition from consciousness to unconsciousness. The jerks themselves are involuntary muscle spasms that occur during the hypnagogic state, that liminal space between wakefulness and sleep, where your brain is neither fully engaged with the external world nor fully committed to the dream state, and they often come accompanied by vivid, fragmentary images or the sensation of falling, as if your body is reacting to some genuine threat that your conscious mind cannot identify or understand. Neurologists have proposed various theories over the decades to account for these spasms, including suggestions that they represent evolutionary remnants from our primate ancestors, a reflexive jerking movement that would have helped them avoid falling from trees during sleep, or that they might be related to the sudden shift in muscle tone that occurs when your body begins to relax into sleep, creating a kind of mismatch between your nervous system's expectations and your body's actual state. In the small town of Taos, New Mexico, a phenomenon has persisted for decades that defies conventional explanation. A low-frequency humming sound that appears to emanate from nowhere and everywhere simultaneously, audible only to certain residents while remaining entirely imperceptible to others who live in the same homes and neighborhoods. Beginning in the 1970s, residents began reporting this mysterious drone, describing it as a constant, pulsating hum that seems to vibrate through the body rather than merely entering through the ears, often more felt than heard. A sensation that builds to maddening intensity for some while remaining completely absent for their closest neighbors just meters away. The Taos Hum has been documented by researchers and journalists, with surveys indicating that roughly 2% of the population experiences it with clarity and distressing regularity. Yet despite extensive investigations by acoustic engineers, military specialists, and government agencies, no definitive source has ever been conclusively identified or explained. Scientists have proposed numerous hypotheses ranging from low-frequency electromagnetic radiation to unusual atmospheric conditions, tinnitus triggered by shared environmental factors, or even mass psychogenic illness, where the power of suggestion creates the perception of sound where none objectively exists. Yet each theory crumbles under scrutiny because the experiences reported are far too specific and consistent across different individuals who have no prior knowledge of each other's encounters. What persists in the case of the Taos Hum is a fascinating paradox where documented experiences meet the complete absence of measurable evidence, where technological instruments designed to detect such frequencies consistently register nothing, while human witnesses maintain absolute certainty in what they experience, creating a chasm between subjective reality and objective measurement that modern science has found nearly impossible to bridge. Leaving this mystery suspended in the uncomfortable space between legitimate phenomenon and elaborate collective delusion. Imagine a single bubble, impossibly small, trapped in water and subjected to relentless sound waves, pulsing at frequencies so high that human ears cannot perceive them, and yet this bubble, this microscopic sphere of air, begins to emit light, faint but measurable, photons released from what should be nothing more than collapsing gas. This phenomenon is called sonoluminescence, and it represents one of the most perplexing contradictions in modern physics, where sound energy converts into visible light through a mechanism that science has observed countless times but still cannot fully explain. When acoustic cavitation occurs, bubbles form and collapse in liquid under intense ultrasonic radiation, and during those final nanoseconds of implosion, the gases inside compress to extraordinary temperatures and pressures, theoretically reaching conditions hotter than the surface of the sun, conditions so extreme that they should trigger nuclear fusion reactions. Yet the energy output suggests something far stranger is occurring. Researchers have documented this effect repeatedly in laboratories around the world, measuring the precise wavelengths of light, noting that the effect intensifies under specific conditions. Yet the underlying mechanism remains stubbornly resistant to complete understanding, as if nature is performing a magic trick directly before our instruments while refusing to reveal how the illusion is constructed. The bubble wall moves inward at speeds approaching the speed of sound itself, creating shock waves that propagate through the imploding gas, heating it to plasma states, and theoretically this compression should produce the observed light through simple thermodynamic principles. And yet calculations consistently show that the measured light output exceeds what these temperatures alone should generate, suggesting additional energy sources or conversion mechanisms that remain unidentified. Imagine a photon or particle of light traveling through a sophisticated laboratory apparatus designed to test the very nature of reality itself, and picture yourself standing at the observation point where a fundamental question emerges. Does the universe decide what something is before we measure it, or does the act of measurement retroactively determine what that thing has always been? This is the essence of the delayed choice experiment, a quantum mechanics thought experiment first proposed by physicist John Wheeler in 1984, which suggests that the future choices we make about how to measure a particle can somehow influence how that particle behaved in the past, long before we ever decided to measure it. In the actual setup, a photon is sent toward a half-silvered mirror, a device that allows light to both reflect and pass through simultaneously, creating a superposition where the photon exists in multiple states at once, traveling along two different paths simultaneously through the apparatus. The crucial twist arrives when we consider the measurement choice. If we choose to measure which path the photon actually took, the photon collapses into having taken one definite path, behaving like a particle with a specific trajectory. However, if we delay this measurement choice until after the photon has already begun its journey, or even retroactively decide not to measure the path at all, the photon instead exhibits wave-like behavior, having effectively traveled both paths simultaneously. The psychological mechanism underlying our struggle with this concept involves our deeply ingrained assumptions about causality and time's arrow, our fundamental belief that causes must precede effects, that the past is fixed and immutable, and that our present actions cannot possibly reach backward to reshape historical events. In the depths of the ocean, there exists a creature that appears to have unlocked one of nature's most fundamental secrets: the ability to reverse its own aging process and achieve a form of biological immortality that defies everything we understand about the progression of life and death. The immortal jellyfish, scientifically known as Turritopsis doanea, is a small translucent organism barely larger than a human fingernail, yet it possesses a capability that has captivated marine biologists and gerontologists for decades, a process so unusual that it seems to operate outside the normal rules governing all other living things on this planet. When the immortal jellyfish reaches maturity and faces the inevitable pressures of aging, disease, or starvation, rather than dying like every other organism in the known animal kingdom, it instead undergoes a remarkable transformation called transdifferentiation, in which its cells essentially reset themselves and revert back to their earliest developmental stages, essentially sending the jellyfish backward through its own life cycle to begin again as a juvenile. This biological mechanism functions through a process where the mature medusa form of the jellyfish transforms itself into a polyp, which is a younger developmental stage, allowing the creature to theoretically regenerate indefinitely and experience an endless cycle of renewal rather than permanent death. The profound strangeness of this phenomenon lies not merely in its existence, but in how such a process could have evolved at all, why such an organism would possess genetic instructions for self-rejuvenation when no other complex animal has developed this ability, and how such a mechanism manages to function without accumulating the cellular damage and mutations that would logically render it cancerous or non-functional within a finite number of cycles. In the remote and desolate expanse of Death Valley, specifically within a dry lake bed known as Racetrack Playa, a phenomenon persists that has puzzled scientists and captivated the imaginations of curious travelers for decades. A phenomenon wherein massive boulders, some weighing hundreds of pounds, appear to move across the barren ground of their own volition, leaving long trails etched into the salt-crusted earth behind them as if guided by invisible hands. These rocks, which locals and researchers have come to call sailing stones, demonstrate movement that cannot be easily explained by conventional understanding, gliding across vast distances across the flat terrain without any visible or immediately apparent mechanism propelling them forward, and the trails they leave behind create intricate patterns that suggest deliberate journeys rather than random displacement. The stones vary dramatically in size and weight, ranging from relatively modest pebbles to massive boulders that would require tremendous force to move even slightly. Yet somehow they traverse the playa over the course of months or years, their movements seemingly timed to specific seasonal conditions that researchers have struggled to definitively identify and confirm. For generations, these movements remained completely unexplained, spawning theories both scientific and fantastical, from magnetic anomalies to supernatural forces. Yet the truth of the phenomenon seemed to elude even the most rigorous investigation. The psychological mechanism that has allowed this mystery to persist involves our deep human tendency to accept phenomena we observe directly, even when we cannot explain them, creating a kind of narrative immunity wherein the strange becomes normalized simply through repeated observation and cultural transmission. We become comfortable with mystery when it appears consistent, when it follows patterns we can at least recognize and map, and the sailing stones fit perfectly into this category of acceptable unknowns. Deep in the vast emptiness of space, traveling beyond the orbit of Neptune toward the edge of our solar system, two spacecraft named Pioneer 10 and Pioneer 11 have been drifting for decades in a condition that defies our most fundamental understanding of physics. These twin vessels, launched in the early 1970s, were equipped with instruments to study the outer planets and the solar wind, but as they continued their silent journey away from Earth, scientists monitoring their trajectories began to notice something profoundly troubling. Both spacecraft were slowing down in a way that could not be accounted for by any known force. The deceleration was subtle, almost imperceptible, but it was consistent and measurable, suggesting that some invisible influence was gently pulling these machines backward toward the sun with an acceleration of approximately 1/1000th of a gravity. This phenomenon became known as the Pioneer anomaly, and for over 3 decades, it remained one of the most perplexing mysteries in space exploration. When scientists calculated the expected trajectories based on the gravitational influence of the sun and planets, the Pioneer spacecraft simply did not behave as predicted. They arrived at certain points in space earlier than the equations said they should, implying they were being held back by something that the laws of motion, as we understand them, could not explain. The psychological weight of this mystery lies in its implication that our most precise mathematical descriptions of the universe might be incomplete or fundamentally flawed, a notion that creates a deep unease in the scientific community because it suggests that even in the vast, relatively empty expanse of space, there are forces at work that remain invisible to us, that resist our attempts to quantify and understand them. There exists a neurological phenomenon so peculiar and disorienting that it challenges our most fundamental understanding of consciousness and perception, a condition known as blind sight, wherein individuals who have suffered damage to the primary visual cortex report having no subjective visual experience whatsoever, yet somehow retain the ability to navigate their environment, identify objects, and respond to visual stimuli with surprising accuracy despite being completely unaware that they are doing so. Patients with blind sight often describe their visual field as a blank void, an absence of sight so complete that they may insist they cannot possibly perceive anything before them. And yet when prompted to guess the location of an object or the direction of movement, they perform far better than random chance would predict, as though some hidden part of their brain possesses visual information that never reaches their conscious awareness. The mechanism behind this phenomenon appears to involve alternative visual pathways that bypass the damaged primary visual cortex entirely, including the superior colliculus and other ancient neural structures that evolved long before the development of conscious visual perception. Pathways that retain the ability to process motion, location, and basic visual properties without any accompanying sense of seeing or knowing that they are functioning. What makes blind sight particularly unsettling is not merely the dissociation between visual ability and visual awareness, but rather what it reveals about the nature of consciousness itself, suggesting that vision and the subjective experience of sight are not one unified process, but rather two potentially independent systems that can operate in complete isolation from one another. Consider the octopus, a creature whose cognitive abilities seem to operate according to rules entirely foreign to what we understand about how intelligence should develop and function in the animal kingdom. These soft-bodied cephalopods, which diverged from vertebrate evolutionary lineages nearly 600 million years ago, possess nervous systems that are fundamentally structured in ways that bear almost no resemblance to mammalian or avian brains, and yet they demonstrate problem-solving capabilities, tool use, playfulness, and even what appears to be individual personality traits that rival those of animals we consider far more intelligent by conventional standards. The octopus brain contains roughly 500 million neurons, which might seem modest compared to human brains, but what makes this truly perplexing is that approximately two-thirds of these neurons are distributed throughout the octopus's 8 arms rather than centralized in its head, meaning the arms possess a form of semi-autonomous intelligence that can solve problems and navigate obstacles independently while the central brain attends to other concerns. Laboratory observations have documented octopuses manipulating objects with remarkable dexterity, opening child-proof containers to access food, recognizing individual humans, and responding differently to those who have treated them kindly versus those who have not, and even engaging in what researchers describe as play behavior with objects that offer no nutritional or survival value. Some specimens have demonstrated the ability to plan for the future by gathering and arranging rocks before they are needed as shelter, suggesting a temporal awareness that extends beyond immediate present circumstances. Imagine two particles that have been created together, entangled in such a way that their properties are fundamentally linked across any distance. And then imagine separating these particles so far that light itself could not travel between them in the lifetime of the universe. Yet when you measure one particle and discover it has a particular spin or polarization, the other particle instantaneously exhibits the complementary property. As if information traveled between them faster than the speed of light itself, which should be impossible according to everything we understand about the fabric of reality. This is the essence of what Einstein, Podolsky, and Rosen described in their famous thought experiment published in 1935, a puzzle that has haunted physics for nearly a century and continues to challenge our fundamental assumptions about locality, causality, and the nature of existence itself. The mechanism underlying this paradox emerges from the mathematics of quantum mechanics, which describes particles not as having definite properties before measurement, but rather as existing in superposition, in a state of all possibilities simultaneously until observation forces them into a single state. Yet when two particles are entangled, measuring one seems to instantaneously determine the state of the other, no matter how vast the separation between them becomes. Consider for a moment the tardigrade, a microscopic organism barely visible to the naked eye, a creature so small it could fit thousands across the width of a human hair, yet possessing survival capabilities that seem to defy every biological law we thought we understood about life itself. These tiny animals, sometimes called water bears or moss piglets, have been subjected to conditions in laboratory settings that would instantly annihilate virtually every other living thing on Earth, and yet they endure in ways that continue to perplex and humble the scientific community. Tardigrades have survived exposure to the vacuum of space itself, where temperatures plummet to near absolute zero and cosmic radiation floods through without atmospheric protection, conditions that would instantly desiccate and destroy any known organism, and yet when brought back to normal Earth conditions, these creatures have revived and continued their lives as though nothing remarkable had happened at all. They have survived doses of radiation hundreds of times greater than what would be considered lethal to humans. They have been frozen in liquid nitrogen at temperatures that would crystallize water molecules and shatter cellular structures. They have been exposed to pressures equivalent to those found at the deepest oceanic trenches, where the weight of the entire ocean bears down with crushing force. And in every scenario, many of them simply enter a state called cryptobiosis, form of suspended animation where their metabolism essentially stops, their bodies lose nearly all water content, and they wait in an almost death-like state until conditions become favorable once more. The mechanism behind this phenomenon appears to involve specialized proteins and molecules that protect their cellular structures during these extreme transitions. Yet the complete understanding of how they manage such feats remains frustratingly incomplete despite decades of intensive research. Deep within the cosmic microwave background radiation that fills all of space, scientists have discovered something that should not exist according to our current understanding of the universe, and this anomaly is known as the CMB cold spot. When astronomers mapped the leftover radiation from the Big Bang using sophisticated satellites like the Wilkinson Microwave Anisotropy Probe and later the Planck spacecraft. They expected to find tiny temperature fluctuations distributed randomly and uniformly across the sky, with variations occurring in all directions with roughly equal probability. However, in the southern hemisphere of the cosmic microwave background, researchers identified a region considerably colder than the surrounding areas, a spot roughly 1.4% cooler than the average temperature of this ancient radiation field. This cold spot extends across approximately 10% of the observable sky, making it an enormous anomaly that should theoretically occur only once in 1,000 universes if our models were correct. The implications of this discovery have puzzled cosmologists for decades, as it represents a deviation from the expected distribution patterns that would emerge from the standard Big Bang model and inflationary theory. Scientists have proposed numerous explanations for this phenomenon, ranging from the collision of our universe with another universe existing in higher dimensions, to vast supervoids in space where matter is remarkably sparse, to even more speculative ideas involving topological defects or unusual quantum fluctuations. What makes this anomaly particularly intriguing is that despite our advanced observational capabilities and theoretical frameworks, we cannot definitively explain why this region of space should be colder than everywhere else, yet it persists in our measurements with undeniable clarity. In 1974, Stephen Hawking proposed something that fundamentally challenged our understanding of black holes, those cosmic regions where gravity becomes so intense that nothing, not even light, should be able to escape once it crosses the event horizon. Yet Hawking's calculations revealed that black holes are not entirely black, and that they should emit radiation from their event horizons in a process now bearing his name, a phenomenon that exists at the intersection of quantum mechanics and general relativity, where reality becomes peculiarly contradictory. According to the theory, pairs of virtual particles constantly spontaneously emerge from the quantum vacuum near the event horizon, and in rare instances, one particle falls into the black hole while the other escapes, carrying away energy that we observe as radiation, causing the black hole to gradually lose mass over incomprehensibly long timescales. The stranger aspect of this process is that it appears to violate fundamental principles we hold dear about causality and information preservation, since anything that crosses the event horizon becomes irretrievable, yet the radiation that escapes carries information about the black hole's properties, suggesting something deeper about the universe's bookkeeping mechanisms. We have never directly observed Hawking radiation because detecting it would require black holes far smaller than any known to exist in our universe, since larger black holes emit this radiation at temperatures colder than the cosmic microwave background, making them impossible to distinguish from the universe's radiation noise. The persistence of Hawking radiation as a theoretical framework, despite being fundamentally unobservable, speaks to how we've normalized the acceptance of predictions from equations that remain forever beyond experimental verification, trusting mathematical consistency as our only window into these extreme cosmic phenomena. Have you ever found yourself unable to stop humming or mentally replaying a particular song, melody, or musical phrase that seems to loop endlessly in your mind without your conscious permission or control? This phenomenon, commonly referred to as an earworm or involuntary musical imagery, represents one of the most peculiar and persistent glitches in human consciousness, affecting an estimated 90% of people at least once per week, yet remaining surprisingly resistant to scientific explanation despite decades of neuroscientific investigation. The experience typically begins innocuously enough, perhaps after hearing a song on the radio or in a shop, but then the melody takes on a life of its own, repeating automatically in your mental space for hours or even days, seemingly immune to any deliberate attempt at suppression or distraction. The more you try to think of something else, the more insistently the earworm returns, a paradoxical intensification that suggests some fundamental mechanism of human memory and attention that we have not yet adequately understood. Researchers have proposed various theoretical explanations involving the involuntary engagement of auditory cortex regions and the automatic activation of memory networks, suggesting that certain musical features, particularly those with simple, repetitive, or catchy qualities, somehow hijack our neural resources in ways that are difficult to interrupt. Yet despite these theoretical frameworks, the actual mechanics of why certain melodies become stuck while others do not, why some people experience earworms more frequently than others, and what purpose this repetitive mental phenomenon might serve remain largely mysterious. What makes earworms particularly striking is how universally human they are, how normalized we have become to this involuntary mental looping, treating it as merely an amusing quirk rather than recognizing it as a genuine anomaly of consciousness, where our own minds replay information against our explicit wishes. A small but undeniable loss of volitional control that we simply accept as part of the ordinary experience of being human. On May 1, 1997, hydrophone sensors deployed across the Pacific Ocean by the National Oceanic and Atmospheric Administration detected an extraordinarily powerful and prolonged underwater sound that seemed to originate from somewhere in the southern Pacific, roughly equidistant from the southern tip of South America and the coast of Antarctica. The acoustic signature was unlike anything previously recorded, a low-frequency sound so intense and so geographically widespread that it was picked up by multiple detection stations separated by thousands of miles, and the sound lasted for several minutes, gradually increasing and then decreasing in frequency in a way that suggested a moving source. Scientists named this mysterious phenomenon the bloop, and it immediately captured global imagination because the sheer magnitude and character of the sound seemed consistent with an impossibly large marine creature, perhaps a previously unknown species of whale, or perhaps something far larger and far stranger lurking in the unexplored depths of the world's oceans. The psychological mechanism that made the bloop so captivating to the human mind was our deep-seated susceptibility to mystery wrapped in legitimate scientific measurement, because here was an undeniable, recorded piece of data that seemed to defy conventional explanation, triggering our curiosity about what remains unknown in our supposedly well-mapped world, and speaking to our fear and fascination with the possibility that enormous, undiscovered creatures still inhabit the planet. Years of investigation eventually revealed that the bloop was almost certainly caused by the calving of an iceberg from the Antarctic ice shelf, a massive fracturing of ice that creates acoustic waves of tremendous power. Yet despite this rational explanation, the bloop persists in popular culture and internet mythology as evidence of cryptid marine life. As though the prosaic answer never quite satisfied the deeper yearning to believe that mystery and the truly unknown still exists somewhere beyond our comprehension. Imagine lying in a hospital bed during surgery, completely unconscious according to every medical monitor available, and yet finding yourself floating above your own body, watching doctors work on your physical form from a vantage point near the ceiling, observing details you couldn't possibly know while your eyes were closed, and your consciousness should have been absent, then returning to your body with vivid memories of things you witnessed from that impossible perspective. Out-of-body experiences, or OBEs as researchers call them, represent one of the most perplexing phenomena in human neurology because they occur with striking consistency across cultures, time periods, and psychological profiles. Reported by surgeons and patients alike, by skeptics and believers, by people on their deathbeds, and by those in perfect health. The experiences typically involve a complete dissociation from physical reality, a sensation of movement through space while remaining fully conscious and aware, and often an overwhelming sense that the observer's true self has separated from the material body and now exists independently in space. Medical science attributes these experiences to disruptions in the temporoparietal junction of the brain, that region responsible for spatial awareness and self-perception. Yet this explanation struggles to account for the specificity and accuracy of details reported by people experiencing OBEs. Particularly those who describe witnessing events in rooms they've never seen before, or recalling conversations held during moments when brain activity showed no patterns consistent with conscious awareness. What makes out-of-body experiences so persistently mysterious is that we have essentially normalized them within psychological frameworks without actually resolving the fundamental contradiction they present. The brain's electrical activity cannot produce consciousness during the moments when it appears completely inactive, and yet consciousness persists with such clarity and purpose that witnesses describe it as more vivid than ordinary waking life. Consider the fundamental constants that govern our reality: the strength of gravity, the electromagnetic force, the mass of electrons, the speed of light. Each one appears to be calibrated with almost impossible precision, as if someone turned infinite dials to exact positions that allow stars to form, planets to exist, and ultimately consciousness itself to emerge from the void. If gravity were even slightly stronger, matter would have collapsed into black holes within microseconds of the Big Bang, leaving no time for complexity to develop. If it were weaker, particles would have dispersed too rapidly for any structures to coalesce. The same precarious balance applies to every fundamental force and constant we observe, and the mathematical odds of these values aligning by pure chance have been calculated by physicists to be so vanishingly small that the number stretches into incomprehensible depths of improbability. We live in what appears to be one of perhaps 10 to the power of 120 possible universes where the parameters would support any form of life whatsoever. Yet somehow we find ourselves in this one, the one that works, the one that breathes with just the right composition of fundamental forces. The human mind responds to this reality with a peculiar mixture of wonder and unease, and we have developed various frameworks to process it. Some invoke the multiverse hypothesis, where infinite universes exist with infinite parameter combinations, and we simply observe the one we can exist in. Others suggest an anthropic principle, where the universe must appear fine-tuned to us, because we could not exist otherwise to observe any other version. And still others point toward deeper mathematical structures we have not yet discovered that would explain why these particular values are inevitable rather than arbitrary. Imagine driving on a long, straight highway on a clear afternoon, the road stretching endlessly before you in a perfectly predictable pattern, mile after mile of asphalt and white lines blurring together in your peripheral vision as you maintain a steady speed. You've been driving for what feels like 20 minutes, but suddenly you realize with a jolt of confusion that an hour has passed, and you cannot recall a single moment of the journey, no memory of the towns you passed through or the exits you chose, no recollection of making any conscious decision about steering or acceleration. And yet somehow you have safely navigated every turn and maintained your lane with perfect precision the entire time. This is highway hypnosis, a dissociative state that seems to contradict everything we understand about conscious awareness and vehicle operation, a phenomenon where your mind and body appear to operate on two entirely separate channels, one handling the mechanical demands of driving with flawless execution, while the other drifts into a dreamlike fog of absent awareness. The mechanism behind this strange occurrence involves the way your brain processes routine, repetitive tasks, particularly when the environment provides consistent visual patterns and minimal stimulation requiring conscious attention. When driving conditions are predictable and unchanging, your brain essentially delegates the task to your basal ganglia, a primitive region that handles automatized behaviors, freeing your prefrontal cortex to wander into thought, memory, or even a state resembling light sleep. The road itself becomes hypnotic through the repetition of visual cues, the monotonous drone of the engine, the consistent vibration of the vehicle, and the unchanging sensory input, all of which lull your conscious mind into a passive state, while your automatic systems remain vigilant and responsive to unexpected changes in the environment. In the vast and largely unexplored depths of our oceans, there exists a creature whose voice represents one of the most haunting mysteries in marine biology, a phenomenon that has captivated scientists and the public imagination alike for decades. Since 1987, researchers tracking whale populations using hydrophone arrays designed to monitor the vocalizations of various cetacean species began detecting a peculiar sound that did not match any known whale species. A call that resonated at approximately 52 Hz, significantly higher in frequency than the typical calls of blue whales, which average at around 10 to 15 Hz, or fin whales, which produce frequencies around 20 Hz. This unique acoustic signature suggested the presence of an individual whale of unknown species, one that has continued to produce these distinctive calls across multiple ocean basins over more than 3 decades, traveling vast distances while apparently remaining isolated from other whales that might recognize or respond to its vocalizations. The creature, which has become colloquially known as the 52 Hz whale, produces calls that are distinct enough to be consistently identified by acoustic monitoring systems, yet anomalous enough that no marine biologist has definitively determined what species it belongs to, whether it might be a hybrid of two species, or whether it suffers from some form of physiological difference that prevents it from producing the normal frequency range of its own kind. What makes this phenomenon psychologically compelling is the narrative we have constructed around it, the interpretation that this whale is fundamentally alone, unable to communicate with its own kind, producing a call that echoes through the ocean unanswered, a concept that resonates deeply with human experiences of isolation and disconnection. Deep beneath the arid soils of East Africa, a peculiar creature exists that seems to operate under a completely different set of biological rules than nearly every other mammal on Earth. And this creature is the naked mole rat, a small, wrinkled rodent that possesses immunological properties so extraordinary that researchers still struggle to fully comprehend how such a system could have evolved, or why it functions so differently from our own. Unlike virtually all other mammals, including humans, the naked mole rat appears to possess an almost supernatural resistance to cancer, with studies showing that these animals rarely, if ever, develop malignant tumors throughout their entire lifespans, which can extend well beyond 30 years in captivity, an unusually long life for a rodent that should theoretically succumb to cellular mutations and cancerous growths far more frequently. Scientists have discovered that naked mole rats possess a modified version of a tumor suppressor protein called P16, which functions with remarkable efficiency in detecting and neutralizing cells that have begun their transformation into cancer. And they also possess extra copies of genes that enhance their cellular repair mechanisms. Yet the true mystery lies not simply in the presence of these genetic features, but in how they work in concert with the animal's entire physiological system to create what appears to be nearly complete immunological impenetrability. Imagine two uncharged metal plates positioned parallel to each other in a perfect vacuum, separated by only a few micrometers of empty space, and imagine that these plates, despite having no obvious force acting upon them, begin to move toward each other with a measurable and reproducible force that pushes them together. This is the Casimir effect, discovered in 1948 by Dutch physicist Hendrik Casimir, and it represents one of the most peculiar phenomena in physics because it suggests that empty space is not actually empty at all, but instead seethes with virtual particles constantly appearing and disappearing in a quantum dance that we cannot directly observe yet can definitively measure. The theoretical mechanism behind this effect relies on the understanding that the quantum vacuum is not a passive void, but rather a dynamic medium filled with what physicists call quantum fluctuations, where particle-antiparticle pairs spontaneously materialize and annihilate in timescales so brief that they technically violate the laws of energy conservation, yet they do so within the bounds of Heisenberg's uncertainty principle, which permits such brief violations at extremely small scales. When two metal plates sit in this turbulent quantum soup, the space between them can only accommodate virtual particles with wavelengths shorter than the distance separating the plates, while the space outside the plates can accommodate a broader spectrum of wavelengths, which theoretically means there are more virtual particles pushing from the outside than from within, creating a net inward force that brings the plates together. Imagine yourself standing in a crowded room filled with dozens of conversations happening simultaneously, glasses clinking against tables, laughter erupting from different corners, music playing softly in the background, and yet somehow, miraculously, you are able to focus entirely on the voice of the single person standing directly in front of you, filtering out nearly all of that overwhelming auditory chaos with such precision that you can understand every word they are saying without asking them to repeat themselves. This phenomenon, known as the cocktail party effect, represents one of the most peculiar capabilities of human attention and perception, an ability so fundamental to our social existence that we rarely pause to consider how deeply strange it actually is. Your ears are receiving hundreds of distinct sound waves at any given moment in such an environment, yet your brain somehow possesses the remarkable capacity to selectively amplify certain frequencies while simultaneously suppressing others, allowing you to maintain a coherent conversation in conditions that should theoretically make such communication entirely impossible. Scientists have proposed that this selective attention operates through a combination of mechanisms, including our ability to focus on specific spatial locations, our recognition of familiar voices and speech patterns, and our unconscious processing of what researchers call bottom-up and top-down attention signals. The brain appears to prioritize certain auditory information based on its relevance to you personally, your expectations about what someone might say next, and the emotional significance of particular voices or conversations. Yet despite decades of neurological research and our increasingly sophisticated understanding of how the brain processes information, we still cannot fully explain why this system works so effectively, or why it sometimes fails completely, leaving us unable to hear our own names being called across a crowded room even though we were supposedly listening intently to something else. In the realm of crystallography, where scientists have long understood the rules governing how atoms arrange themselves into orderly, repeating patterns, there exists a peculiar category of matter that seems to violate those very principles in ways that still unsettle researchers today. Quasicrystals are structures that possess a long-range order without periodicity, meaning they display symmetrical patterns that repeat in ways that should be geometrically impossible according to classical crystallography. Yet they undeniably exist in nature and can be synthesized in laboratories. The atoms within these materials organize themselves following mathematical rules based on irrational numbers and golden ratio proportions, creating patterns that never truly repeat, that shift infinitely without ever returning to their original configuration, defying the traditional definition of what a crystal fundamentally is. When scientists first discovered quasicrystals in 1982 in a laboratory setting, the academic community reacted with profound skepticism, for the very concept seemed to contradict the bedrock principles upon which crystallography had been built for centuries. The discovery appeared so anomalous that the initial paper was rejected by numerous journals before finally being published, yet the phenomenon proved reproducible, verifiable, and eventually undeniable. What makes quasicrystals particularly unsettling is not merely that they exist, but that nature produces them spontaneously in certain meteoritic materials and mineral deposits, suggesting that the universe operates with architectural principles far more nuanced and mathematically sophisticated than our previous frameworks acknowledged. The symmetries present in quasicrystals include five-fold rotational symmetries that classical geometry insisted could never create stable, repeating structures, and yet these arrangements prove remarkably stable and energetically favorable under specific conditions. Deep within the region where the Catatumbo River meets Lake Maracaibo in Venezuela, there exists a phenomenon so persistent and so peculiar that it has earned the title of one of Earth's most concentrated lightning hotspots, yet remains fundamentally mysterious in its precise mechanisms and origins. For centuries, indigenous peoples witnessed what they called the Maracaibo Beacon, a nearly constant display of electrical storms that illuminate the night sky with such frequency and intensity that the phenomenon occurs on approximately 180 days per year, with lightning striking the area up to 28 times per minute during peak activity. The lightning itself does not follow conventional patterns, instead occurring primarily in the upper atmosphere rather than between clouds and ground in the typical manner we observe elsewhere on the planet, creating brilliant sheets and columns of light that can be seen from over 250 miles away. Yet the exact atmospheric conditions that trigger and sustain this perpetual electrical display remain largely unexplained by modern meteorological science. Scientists have proposed various theories involving the unique geography of the region, including the way the Andes Mountains funnel moisture-laden trade winds, the methane emissions from decomposing vegetation in the surrounding wetlands, or some combination of localized temperature inversions and mineral deposits. Yet none of these explanations fully accounts for why Catatumbo maintains such extraordinary consistency compared to other lightning-prone regions across the globe. The phenomenon demonstrates a paradoxical quality where it is both extensively documented and fundamentally enigmatic, appearing in countless photographs and meteorological records, yet defying complete scientific understanding despite decades of dedicated study and observation from researchers who have traveled to witness it firsthand. Perhaps no creature on Earth has managed to keep its reproductive secrets quite as thoroughly as the common eel, a slippery and enigmatic animal that has eluded scientific observation for centuries in ways that seem almost deliberately obstinate. What makes this phenomenon particularly unsettling is that eels spend their entire lives in rivers and freshwater lakes, yet no one has ever witnessed them mating or reproducing in these familiar habitats, and no one has ever found eel eggs or larvae in the waters where adult eels thrive. Instead, scientists have pieced together a fragmentary understanding suggesting that eels undergo a remarkable transformation called metamorphosis, before embarking on an extraordinary migratory journey across the Atlantic Ocean toward the Sargasso Sea, a mysterious region of the North Atlantic where they are believed to spawn, though direct observation of this spawning remains virtually non-existent even in modern times. The psychological mechanism that allows us to accept this extraordinary gap in our knowledge is rooted in how we compartmentalize incomplete information. We assign the phenomenon to the category of things that are simply difficult to study rather than acknowledging the deeper strangeness of an animal that refuses to reproduce where we can observe it, almost as though the eel has evolved specifically to maintain mystery. What persists as truly remarkable is how we have normalized this profound ignorance by transforming it into a neat biological narrative, complete with speculative details about depth and location and timing, when in reality we are describing an animal whose most fundamental life process remains utterly hidden from human scrutiny. Unobserved and unverified despite centuries of scientific inquiry and technological advancement that has allowed us to glimpse the surfaces of distant planets, yet somehow continues to fail in revealing where eels actually mate or how their reproductive cycle truly functions in any direct, observable way. Have you ever walked into a room with a clear purpose in mind, only to find yourself standing there moments later, completely bewildered about why you entered in the first place? You stand in the doorway or just past the threshold, searching your memory for the intention that seemed so vital just seconds before, and the harder you grasp for it, the more elusive it becomes. This phenomenon, known as the doorway effect, remains one of the most universally relatable yet scientifically perplexing quirks of human memory and cognition. Researchers have documented this experience extensively through controlled laboratory studies where participants navigate between rooms, either physical spaces or virtual environments, and attempt to complete tasks or recall information they held in their minds before crossing through doorways. The results consistently show that crossing a threshold creates a measurable disruption in working memory, as if the simple act of passing through a physical boundary causes our minds to compartmentalize information and essentially reset certain cognitive processes. The leading explanation involves something called event segmentation, where our brains naturally divide our experiences into distinct episodes or chapters, and doorways, being obvious physical and environmental markers, serve as powerful dividing lines that signal our minds to close one mental file and open another. When we cross through a doorway, our brain interprets this transition as a natural conclusion to one episode and the beginning of another, causing it to essentially file away the previous context and prepare for new information. Yet despite understanding this mechanism, the doorway effect persists with remarkable consistency across all ages and cognitive abilities, suggesting that this mental quirk is so deeply embedded in how our brains process space and time that awareness of the mechanism provides little protection against experiencing it. Deep within the carefully controlled environment of scientific laboratories, physicists have observed something that should not exist according to our most fundamental understanding of how reality operates, and this phenomenon involves a subatomic particle called the muon, which is similar to an electron but significantly heavier and far more unstable. When scientists measure a particular property of the muon known as its magnetic moment, or more precisely, the anomalous magnetic moment represented by the symbol G-2, they consistently find values that deviate from what the standard model of particle physics predicts with extraordinary precision. The standard model is humanity's best attempt to describe how particles interact and behave, a framework built upon decades of experimental verification and theoretical refinement. Yet when researchers at Fermilab in Japan's JPRC facility measure this muon property, the measurements disagree with theoretical predictions by an amount that seems small on the surface, but is statistically significant enough to suggest something fundamental is missing from our understanding. The psychological mechanism at work here involves the deep human reliance on mathematical frameworks and predictive models, a reliance so complete that when nature refuses to match our equations, we experience a genuine cognitive dissonance. The muon anomaly persists because it exists at the boundary between what we can measure with extreme precision and what our theories can calculate with equal precision, creating a gap that cannot be dismissed as experimental error or rounding mistakes. What makes this phenomenon particularly unsettling is that the discrepancy could indicate the existence of entirely new particles or forces that we have not yet discovered, particles that would interact with muons in subtle ways that our current instruments cannot directly observe. High above the Earth, in the mesosphere where the air grows thin and the darkness of space begins to assert itself, there exists a phenomenon that defies our conventional understanding of lightning and atmospheric electricity, a ghostly manifestation of energy that appears as brief, brilliant flashes of red light dancing silently above thunderstorms, visible only from certain vantage points and fleeting away in fractions of a second, leaving observers questioning whether they truly witnessed what their eyes captured. These are red sprites, transient luminous events that occur at altitudes between 50 and 90 kilometers above the ground, manifesting as delicate, branching structures of crimson light that spread outward and downward like jellyfish tentacles or coral formations suspended in the upper atmosphere. And yet, despite decades of scientific investigation and satellite observations that have documented thousands of these occurrences, we remain fundamentally uncertain about the precise mechanisms that generate them and why they behave with such apparent intelligence and directional awareness. The conventional explanation suggests that red sprites result from a massive electrical potential difference between the thunderstorm clouds below and the upper atmosphere, causing electrons to cascade through the thin air and ionize oxygen molecules, which subsequently emit the characteristic red wavelengths as they return to their ground state. Yet this explanation fails to account for several persistent anomalies, including the seemingly purposeful structure of individual sprites, their rapid organization into coherent patterns, and their apparent response to specific electrical conditions in ways that seem far more complex than simple electron cascades would suggest. Imagine losing your sight entirely, watching the world collapse into darkness, only to find that your mind refuses to accept this absence and instead begins to populate the void with elaborate, vivid hallucinations that feel completely real. This is the experience of Charles Bonnet syndrome, a remarkable neurological phenomenon where individuals who have experienced significant vision loss or blindness begin to perceive complex visual hallucinations that they themselves recognize as unreal, yet which persist despite this knowledge and despite occurring to people of sound mind and clear cognitive function. These are not the fleeting images of imagination, but rather intricate scenes, geometric patterns, faces of strangers, animals moving through space, sometimes entire landscapes unfolding in perfect detail, accompanied by full color and dimension, appearing spontaneously without warning or invitation. The syndrome typically emerges in older adults who have experienced vision loss due to conditions like macular degeneration or cataracts, though it can occur at any age following significant visual impairment, and the hallucinations can last from seconds to hours, recurring unpredictably throughout the day or evening. What makes this condition philosophically unsettling is that the brain, suddenly deprived of visual input from the external world, does not simply sit in silence, but instead activates its own visual cortex, generating experiences with such vividness and coherence that they rival actual perception, creating an internal cinema that plays without a script or apparent purpose. The mechanism appears to involve the brain's attempt to fill sensory gaps, a phenomenon called visual release phenomenon, where the visual cortex, starved of external stimulation, begins firing spontaneously and generating its own imagery, much like a radio picking up static and transforming it into phantom signals. Deep within the molecular architecture of life itself lies one of the most profound mysteries that chemistry and biology have yet to adequately explain. The phenomenon known as homochirality, a condition so fundamental to existence that we rarely pause to consider how utterly improbable it truly is. All living organisms on Earth, from the tiniest bacteria to the largest whales, construct their proteins exclusively from left-handed amino acids, while their DNA and RNA rely solely on right-handed sugars in their backbone structures. This uniformity is so absolute, so pervasive across every known form of life, that it seems almost inevitable in retrospect. Yet the reason why this particular handedness emerged rather than its mirror opposite remains one of science's most stubborn unsolved riddles. When amino acids form naturally in laboratories or are discovered in meteorites, they typically appear in equal proportions of both left and right-handed versions, a 50-50 split that would seem to suggest no preference exists for one orientation over the other. Yet somewhere in the primordial chemistry of early Earth, approximately 4 billion years ago, life chose a direction and never deviated from it, creating a cosmic asymmetry that pervades all terrestrial biology. Scientists have proposed numerous mechanisms to explain this preference, from circularly polarized light from distant stars influencing molecular formation to random events being amplified through autocatalytic chemical processes. But none of these explanations fully account for why this particular choice became universal and irreversible across the entire biosphere. The psychological mechanism at work involves our tendency to accept established patterns as natural law rather than fortunate accident, and we have so thoroughly normalized homochrality that alternative possibilities seem almost unimaginable, despite their theoretical equal likelihood. Across the arid grasslands of Namibia, particularly in the Namib Desert, there exists a phenomenon that has puzzled scientists, locals, and researchers for generations. Vast circular patterns of barren ground that appear as if drawn by an invisible hand, each one perfectly formed with a ring of vibrant grass surrounding a dead center where nothing grows. These formations, known as fairy circles, can range from a few meters to over 60 meters in diameter, and they stretch across the landscape in seemingly random distribution, creating an almost choreographed pattern that feels far too intentional to be mere coincidence. The circles are so distinctive that they can be clearly observed from aerial photographs and satellite imagery, appearing as if some otherworldly force has deliberately scorched the earth in these precise geometric patterns. For centuries, the indigenous Nama people attributed these circles to the footsteps of gods or the presence of supernatural beings, stories that persisted because the circles themselves seemed to defy logical explanation. Scientists have proposed numerous theories over the decades, including underground termite colonies that consume vegetation, chemical toxins in the soil that prevent plant growth, or self-organizing vegetation patterns that emerge from competition for scarce water resources in extremely arid environments. Yet despite intensive research and numerous field studies, no single explanation has achieved complete consensus among the scientific community, and the mechanism that creates and maintains these perfect circles remains partially mysterious. The circles seem to follow a natural spacing pattern that prevents them from appearing randomly, but also prevents them from clustering, suggesting some form of underground communication or resource distribution system that we still do not fully comprehend. What makes fairy circles particularly unsettling is not that they exist, but that we live in an age of advanced technology and ecological science, yet we still cannot definitively explain why the Earth itself seems to be organizing into these geometric patterns across an entire landscape. In the depths of forest floors and decaying logs across the world exists an organism so peculiar that it challenges everything we thought we understood about consciousness and intelligence itself. A gelatinous mass of cells called slime mold that possesses no brain, no nervous system, and no neurons whatsoever, yet somehow demonstrates problem-solving abilities that rival small animals in their sophistication. When researchers have observed these organisms navigating complex mazes, they have consistently found that slime molds can discover optimal routes through trial and error, adapting their growth patterns to avoid obstacles and find the most efficient path to food sources with a seemingly purposeful deliberation that defies explanation. The creature, known scientifically as Physarum polycephalum, operates as a single-celled plasmodium that can grow to cover an area larger than a human hand, yet maintains a unified sense of direction and purpose despite having no centralized command center directing its movements. Scientists have discovered that these organisms can somehow share information across their body without chemical signaling or electrical impulses in the way we understand them, creating synchronized patterns of contraction and expansion that allow different regions of the slime mold to communicate and coordinate their actions toward a common goal. When placed in environments with multiple food sources, slime molds demonstrate what appears to be intentional decision-making, choosing between options as if weighing the nutritional value and proximity of each alternative with some form of biological calculation. The fundamental mystery that persists despite decades of study is precisely how a creature without any structures we associate with thought processes can engage in what appears to be conscious deliberation and strategic planning. Imagine you are sitting in a dimly lit room, staring directly at a single point on the wall in front of you, perhaps a small mark or a light switch, and you decide not to move your eyes away from that focal point for an extended period of time. At first, everything in your peripheral vision remains perfectly visible to you, The colors of the surrounding walls, the shapes of furniture in the corners of your vision, all of it crisp and clear and present in your awareness. But as the seconds pass and you maintain that unwavering focus, something peculiar begins to occur in the regions surrounding your central point of fixation. The colors seem to fade, the edges of objects in your peripheral vision become increasingly blurred and indistinct, and gradually, almost imperceptibly, entire portions of your visual field simply vanish from your conscious perception, as though they have been erased from reality itself, even though you know intellectually that they are still there. This phenomenon is known as the Troxler effect, named after the Swiss physician Ignaz Paul Vitali Troxler, who first documented and described this strange visual occurrence in the early 1800s. The mechanism behind this effect is rooted in how our visual system actually processes information. Our eyes are not cameras that passively record everything before them with equal clarity and detail. Instead, our visual perception is an active, dynamic process where our brain constantly samples information from our surroundings, paying close attention to changes, movements, and areas of interest, while simultaneously filtering out what it deems to be redundant or unchanging information. When you hold your eyes perfectly still on a single point and do not allow that point of focus to move, the neurons in your retina that are responsible for detecting the stationary images in your peripheral vision gradually become adapted to the constant stimulus. This neural adaptation causes those peripheral neurons to cease firing at their normal rate, effectively signaling to your brain that there is no new information coming from those regions. Deep within marshes and wetlands across centuries of recorded history, travelers have reported witnessing unexplained floating lights that seem to dance and hover just beyond reach, leading them further into treacherous terrain where they often become hopelessly lost. And these luminous phenomena, known as will-o'-the-wisps or ignis fatuus, represent one of the most persistent yet scientifically elusive mysteries of our natural world. The accounts are remarkably consistent across cultures and continents. Witnesses describe seeing pale blue or greenish lights that appear roughly a meter or two above the ground, moving with an almost intelligent purpose, flickering and retreating whenever approached, as if deliberately taunting those who chase them into the darkness. What makes these observations so troubling is not merely that they occur, but that they have continued to occur in modern times, with documented sightings in Japan, Ireland, Germany, and North America, each adding credibility to accounts that refuse to be explained away by simple folklore or superstition alone. Scientists have proposed various explanations ranging from the combustion of phosphine gases released from decomposing matter in swamps, to bioluminescent organisms, to electromagnetic phenomena interacting with mineral deposits beneath the earth. And while these theories possess merit and logical foundations, none has yet fully accounted for the intelligence seemingly demonstrated by these lights, their apparent awareness of observers, or their consistent ability to lure individuals into dangerous locations as though guided by some deliberate intention. Deep within the universe, in the cores of stars, and in the aftermath of the Big Bang itself, lithium should exist in far greater quantities than we observe today. Yet this fundamental discrepancy between theoretical predictions and actual measurements remains one of the most perplexing mysteries in cosmology that physicists have been grappling with for decades. When scientists measure the abundance of lithium in the oldest stars in our galaxy, the ones that formed close to the beginning of time itself, they consistently find roughly 3 times less lithium than the Big Bang nucleosynthesis theory predicts should be present, creating what researchers have termed the cosmological lithium problem. The standard model of particle physics and our understanding of how the universe behaved in its first few minutes after the initial expansion suggests specific ratios of elements should have formed, including precise amounts of lithium-7 and lithium-6. Yet when astronomers point their telescopes at ancient stars and analyze their light spectra, the measurements tell a different story entirely. What makes this phenomenon particularly unsettling is that it challenges not just individual theories, but the very foundation of how we understand the universe's birth and early evolution, suggesting either that our measurements are somehow systematically wrong in ways we have not yet discovered, or that something fundamental about our comprehension of nuclear physics and cosmic history requires substantial revision. Scientists have proposed numerous potential explanations ranging from unknown nuclear reactions that could have destroyed lithium in the early universe to the possibility that lithium is being destroyed in stellar interiors through processes we do not fully comprehend. Yet none of these solutions have achieved universal acceptance or fully resolved the discrepancy. In the remote desert landscape of West Texas, approximately 9 miles east of the small town of Marfa, a phenomenon has captured the attention of witnesses, researchers, and curious travelers for well over a century, with documented sightings stretching back to the 1880s when settlers first began reporting mysterious glowing orbs dancing across the night sky in patterns that defy conventional explanation. These lights, which have come to be known as the Marfa lights, appear without warning on clear desert nights, manifesting as distinct luminous objects that hover, pulse, and move with apparent intelligence through the darkness, sometimes splitting into multiple entities, sometimes merging together, sometimes remaining perfectly stationary before suddenly accelerating across impossible distances at speeds that would require extraordinary physical forces. The most striking aspect of these phenomena is their consistency and the sheer number of credible witnesses who have observed them, including law enforcement officers, scientists, pilots, and ordinary citizens whose accounts remain remarkably consistent across generations, describing orbs of white, yellow, orange, or red coloration that exhibit behaviors entirely inconsistent with any known natural phenomenon or conventional explanation. Researchers and skeptics have proposed numerous theories over the decades, ranging from swamp gas and ball lightning to the headlights of vehicles traveling along distant highways. Yet each explanation falls apart under scrutiny because the lights appear in areas where no roads exist. They demonstrate characteristics that contradict the known properties of ball lightning, and they manifest at times in locations where vehicle traffic would be impossible or non-existent. Perhaps most significantly, the Marfa lights phenomenon persists in our collective consciousness and continues to draw scientific interest despite the lack of any satisfactory explanation, demonstrating humanity's peculiar relationship with unexplained phenomena that refuse to conform to our understanding of physics and natural law. Imagine you are watching a film, a simple domestic scene where an actor sits at a table, and in the next shot their coffee cup has disappeared, their shirt has changed color, or the entire background has shifted entirely. Yet you notice nothing at all because the cut between frames was perfectly timed to obscure the alteration. This phenomenon is called change blindness, and it represents one of the most unsettling gaps in human perception, a massive blind spot that exists not in our eyes, but somewhere in the architecture of our consciousness itself. Scientists have documented this effect repeatedly in controlled experiments where participants watch videos or images, and substantial changes occur right before their eyes. A person's face transforms, objects vanish, entire architectural elements shift, yet the observer remains completely unaware that anything has changed at all. The mechanism behind change blindness appears to involve the way our brains allocate attention, which is far more limited and selective than we consciously experience. Our visual system does not actually process the entire visual field with equal detail. Instead, it creates what neuroscientists call a detailed representation only in the areas where we are actively focusing our gaze, while the peripheral vision remains surprisingly sparse in its processing. When a change occurs outside the focus of attention, or during a natural eye movement or blink, the brain essentially has no baseline comparison stored in memory with which to notice the discrepancy, so it simply fails to register that anything has transformed. What makes this phenomenon so persistently mysterious is that despite decades of research and countless demonstrations of its power, we continue to move through the world believing that we see everything with perfect clarity and continuity, when in fact our perception is riddled with these gaps and discontinuities that we are fundamentally blind to. Imagine a liquid so perfectly frictionless that it defies every law of physics we thought we understood about how matter should behave, and this is not the realm of science fiction, but rather a phenomenon that emerges when helium is cooled to temperatures near absolute zero, creating what physicists call a superfluid. When helium-4 reaches approximately 2.2 Kelvin, something extraordinary happens. The liquid loses all viscosity, meaning it flows without any resistance whatsoever, and it can climb the walls of its container, seep through impossibly tiny cracks that would normally seal against ordinary liquids, and rotate in perfect quantum harmony without dissipating any energy. The mechanism behind this strange behavior emerges from quantum mechanics itself, where at extreme cold, the helium atoms enter a state of collective quantum coherence, becoming indistinguishable from one another and moving as a single entity governed by a shared wave function rather than individual particle properties. A superfluid state represents a macroscopic quantum phenomenon, something we typically expect to see only at the subatomic level, yet here it manifests in ways we can observe and measure in laboratories around the world. What makes superfluidity particularly unsettling is that despite being discovered nearly a century ago, and despite our ability to predict it through quantum field theory, it remains profoundly strange and counterintuitive to our everyday understanding of physics. We have accepted this phenomenon into our scientific framework, incorporated it into textbooks and equations, yet it still evokes a sense of wonder because it shows us that reality operates under rules fundamentally different from what our macroscopic intuition suggests, and matter itself is far more exotic and mysterious than our conventional experience would ever lead us to believe. Deep within the quantum realm, where particles dance according to rules that seem to bend the very fabric of what we consider measurable, there exists a discrepancy so subtle yet so profound that it has shaken the foundations of particle physics itself. And this peculiar inconsistency emerged not from philosophical debate, but from the most precise measurements humanity has ever attempted to make. For decades, scientists believed they understood the proton with remarkable accuracy, having calculated its radius through multiple experimental methods that all seemed to converge on a consistent value. Yet when researchers employed a revolutionary technique using muonic hydrogen, replacing an electron with a much heavier muon in an atom of hydrogen, they discovered something deeply unsettling. The proton appeared to be approximately 4% smaller than every previous measurement had suggested. This finding, seemingly insignificant in isolation, rippled through the entire structure of modern physics because the proton radius is not some obscure property, but rather a fundamental constant woven into countless calculations that determine how atoms behave, how light interacts with matter, and how we understand the very building blocks of existence itself. The psychological mechanism underlying this puzzle reveals how science operates within frameworks of accumulated certainty, where repeated confirmations across different experimental approaches create an almost unshakable consensus. Yet this consensus itself becomes the very foundation upon which future measurements are interpreted and judged, meaning that when new data contradicts established values, scientists face a profound cognitive dissonance between trusting their instruments and trusting the weight of historical confirmation. Over the skies of northeastern Australia, particularly in the Gulf of Carpentaria region, a phenomenon occurs that seems to defy the conventional rules of cloud formation and atmospheric behavior, appearing most frequently during the months of September through November, when conditions align in ways that meteorologists still struggle to fully comprehend. These are the morning glory clouds, long tubular formations that stretch across the sky like massive cylindrical waves frozen in time, sometimes extending for hundreds of kilometers in length while remaining relatively narrow in their cross-section, creating an appearance so otherworldly and geometrically precise that observers often question whether they are witnessing natural weather patterns or something far stranger operating beneath the surface of our atmosphere. The clouds typically form during the early morning hours, rolling across the landscape at speeds that can reach 60 kilometers per hour or faster, often accompanied by sudden wind shifts and pressure changes that affect the ground below with an almost mechanical precision that feels deliberately organized rather than randomly generated by atmospheric chaos. Scientists understand that these formations arise from converging sea breezes and complex interactions between warm and cool air masses. Yet the precise mechanism that creates their distinctive tubular structure and allows them to maintain such coherent organization over such vast distances remains incompletely understood and difficult to model accurately through conventional meteorological equations. The phenomenon seems to exist in a liminal space between predictable weather patterns and something that operates according to principles we have not yet fully catalogued, suggesting that our understanding of atmospheric physics may contain significant gaps despite our advanced technologies and decades of atmospheric research. Consider the moment when a yawn overtakes you, that involuntary opening of the mouth accompanied by a deep inhalation and a characteristic facial contortion that seems to spread through your body like a wave, leaving you momentarily suspended in a state between consciousness and sleep. We have observed this behavior in humans for thousands of years, documented its presence across virtually every mammal species, and yet we remain fundamentally uncertain about its true purpose or origin. The conventional explanation suggests that yawning is a response to fatigue, that our bodies employ this mechanism to increase oxygen intake when energy levels decline and alertness wanes. But this theory crumbles under the smallest scrutiny because measurements of blood oxygen and carbon dioxide levels show virtually no change before, during, or after a yawn, suggesting that oxygen replenishment is not the mechanism at work. Instead, researchers have proposed alternative hypotheses ranging from thermoregulation of the brain to the stretching of muscles and stimulation of blood flow to the face and jaw. Yet none of these explanations fully account for the phenomenon's persistence and universality. What strikes us as particularly strange is the contagious nature of yawning, that peculiar social transmission where observing someone yawn or even reading about yawning can trigger the response in ourselves without any physiological necessity present whatsoever. We have normalized this mysterious involuntary action so thoroughly that we barely question it anymore, treating it as merely a mundane biological reflex associated with tiredness or boredom. Yet the actual mechanism remains shrouded in uncertainty and contradiction. Our bodies continue to perform this elaborate ritual multiple times each day, this synchronized stretching and breathing pattern that serves no clearly defined function, and we simply accept it as part of the fabric of human existence, rarely pausing to contemplate why evolution preserved such an action through millions of years if it held no genuine adaptive purpose. Imagine stepping back in time approximately 4.5 billion years to the early formation of our solar system, and you would encounter a profound astronomical puzzle that continues to perplex scientists despite centuries of rigorous study. The faint young sun paradox represents one of the most unsettling contradictions in planetary science, suggesting that our star was substantially dimmer during its youth, radiating only about 70% of the energy it produces today. Yet somehow the young Earth maintained liquid water on its surface and supported the emergence of life, conditions that should have been impossible under such reduced solar radiation. The physics seems irreconcilable because our models of stellar evolution tell us with great certainty that the sun has gradually brightened as it has aged and fused hydrogen in its core, a process as inevitable as gravity itself. Yet the geological and biological evidence from ancient Earth clearly indicates that our planet was warm enough to sustain oceans and microorganisms when the sun should have been casting our world into a frozen, lifeless state. What makes this paradox so psychologically unsettling is that it forces us to confront the possibility that our understanding of either stellar physics or early Earth conditions remains fundamentally incomplete, that somewhere in our models lurks a profound oversight or missing mechanism that we have simply not yet recognized. Scientists have proposed various explanations ranging from enhanced greenhouse gases in the ancient atmosphere that trapped sufficient heat to compensate for the dimmer sun, to the possibility that the early Earth itself was fundamentally different in ways we cannot currently measure. Yet none of these solutions have achieved universal acceptance or fully resolved the contradiction. Imagine being asked to close your eyes and picture a red apple sitting on a wooden table in front of you, and then realize with startling clarity that you cannot do this at all, that your mind produces nothing, no image, no color, no shape, only darkness and an abstract understanding of the concept itself. This is the experience of aphantasia, a neurological variation where individuals lack the ability to voluntarily create visual imagery in their mind's eye, a capacity that most people take so thoroughly for granted that they struggle to comprehend its absence. People with aphantasia can remember that their childhood home had blue walls and a brick fireplace, and they understand these facts completely, but when they attempt to visualize these details, they encounter only void, an absence so profound that it challenges our fundamental assumptions about how human consciousness works. They navigate the world using memory and knowledge in abstract forms, relying on facts and spatial reasoning rather than the mental photographs that most brains automatically generate. Yet they function perfectly well in daily life, holding jobs, driving vehicles, recognizing faces, and engaging in all the activities that sighted people perform. The mechanism behind this variation appears to involve differences in how the visual cortex communicates with other brain regions responsible for memory and consciousness, though the exact neurological pathway remains incompletely understood by modern neuroscience. What makes aphantasia so peculiar is that it reveals something deeply strange about human experience itself. We have built our entire understanding of memory, imagination, and thinking around the assumption that internal visualization is universal, that everyone sees movies in their minds, Yet here exists a significant population of people who simply do not, who have never experienced this phenomenon, and who only discovered its absence when someone asked them to close their eyes and picture something. When a volcano erupts, the ground trembles, ash rises into the sky, and amid this chaos of fire and stone, something extraordinary happens that still defies complete understanding. Brilliant bolts of electricity tear through the volcanic plume, illuminating the darkness with an otherworldly glow that witnesses describe as both terrifying and hypnotic. These volcanic lightning strikes occur within the ash column itself, sometimes hundreds of meters above the volcano's crater, creating a spectacular and chaotic display of electrical discharge that seems to defy the normal rules governing how lightning forms in our atmosphere. The phenomenon has been observed during some of the most violent eruptions in recorded history, from Mount Pinatubo in the Philippines to the Sakurajima volcano in Japan, where photographers and scientists have captured images of multiple lightning bolts branching through towering plumes of volcanic material in a way that appears almost supernatural in its intensity and frequency. The leading scientific explanations suggest that the intense friction generated by countless ash particles colliding with one another as they rise through the volcanic plume creates an enormous electrical charge, similar to how particles in a thunderstorm cloud build up electrical potential through their chaotic motion and collision. The ash particles, being extremely fine and numerous beyond comprehension, rub against each other continuously as they surge upward in the superheated air currents, and this massive transfer of electrons from particle to particle gradually separates positive and negative charges until the electrical potential becomes so great that the air itself can no longer insulate against the discharge, resulting in the dramatic arcing of lightning through the column. Additionally, the volcanic gases and minerals present in the plume, including sulfur compounds and fine silicate particles, may enhance the charge separation process through chemical interactions that are not yet fully mapped out by atmospheric physicists. As spacecraft journey through the vast emptiness of space, traveling at tremendous velocities toward distant planets and beyond our solar system, they experience gravitational interactions with celestial bodies that we have come to expect and understand through centuries of Newtonian mechanics and Einstein's theories of relativity. Yet there exists a peculiar and persistent mystery that has confounded physicists and aerospace engineers for decades, a phenomenon known as the flyby anomaly, wherein spacecraft passing near Earth experience unexpected velocity changes that should not occur according to our most sophisticated mathematical models and gravitational equations. When probes like Galileo, NEAR Shoemaker, Cassini, and Rosetta swung around Earth to gain gravitational assistance for their interplanetary journeys, precise measurements revealed that these spacecraft were traveling either slightly faster or slightly slower than our calculations predicted they should be, deviations that seemed impossibly small yet remained stubbornly consistent. The anomaly appears most pronounced when spacecraft approach Earth at certain angles and velocities, suggesting that something fundamental about how gravitational forces interact with moving objects at high speeds may elude our current understanding, or perhaps some subtle factor in Earth's gravitational field itself remains unmeasured or unaccounted for in our models. Scientists have proposed numerous explanations ranging from undetected atmospheric drag and the influence of solar radiation pressure to relativistic effects we have not yet properly quantified, and even the possibility that our fundamental understanding of gravity itself requires revision in ways we have not yet conceived. You sit in a conversation with friends when someone asks you about that actor from that movie you watched last month, the one with the dramatic scene in the rain, and you know exactly who they mean, the face is vivid in your mind, you can picture their voice and their mannerisms, yet the name simply will not come to you. It hovers at the very edge of your consciousness like a word suspended just beyond the reach of your grasp, and despite your considerable efforts to retrieve it. Your brain obstinately refuses to deliver the information that you are absolutely certain you possess somewhere within the neural networks of your mind. This phenomenon, known as the tip of the tongue effect, represents one of the most peculiar and persistent quirks of human memory, a moment where we find ourselves in the paradoxical position of simultaneously knowing and not knowing something with absolute certainty. The psychological mechanisms underlying this experience are as fascinating as they are mysterious, as researchers believe that the information is indeed stored in your long-term memory, but there exists a retrieval failure occurring at the precise moment when you need access to it, a disconnect between semantic knowledge and the phonological representation of words themselves. Yet what makes this phenomenon so profoundly strange is that it occurs despite our brains having access to partial information. We can often recall the first letter, the number of syllables, or related words, proving that the memory is there waiting beneath some invisible barrier, some neural checkpoint that refuses passage at that exact instant. Beneath the frozen surface of Earth's polar oceans exists a phenomenon so visually unsettling that it challenges our understanding of how water itself should behave, and scientists have only recently begun to comprehend the mechanics behind these structures known as brinicles. Imagine descending through the darkness of Antarctic waters beneath thick pack ice, your vision gradually adjusting to the dim bioluminescent glow filtering down from the frozen world above, when suddenly you encounter a sight that defies intuition. A hollow tube of ice extending downward from the ceiling like an inverted stalactite, sometimes reaching lengths of several meters, its walls translucent and ghostly, its interior filled with brine so concentrated it remains liquid even at temperatures far below freezing. The brinicle forms in a process that begins when salt water at the ice-water interface begins to freeze, but because pure ice crystals form first, the salt gets rejected and expelled downward into the surrounding water, creating an increasingly dense and supercooled brine that sinks and freezes everything it touches in its path, leaving behind this remarkable frozen tube that grows like a spreading cancer through the water column. What makes brinicles particularly strange is how counterintuitive the entire mechanism seems when you first learn about it. For water that is colder should rise, not sink, yet the salt content inverts this expectation and creates a density gradient that pulls the lethal brine downward in a slow, methodical descent that can flash freeze entire ecosystems in its way. Roughly 540 million years ago, during a geological period known as the Cambrian, the fossil record shows something that still confounds paleontologists and evolutionary biologists despite decades of intensive study: an apparently sudden and dramatic diversification of complex animal life forms that had no clear evolutionary predecessors in the rocks below. Before this period, the fossil record reveals only simple, single-celled organisms and soft-bodied creatures of minimal complexity. Yet within a relatively narrow window of geological time, perhaps spanning only 10 to 20 million years, nearly all of the major animal phyla that exist today appear in the fossil record as if emerging from nowhere, fully formed and remarkably diverse in their body plans and ecological strategies. This phenomenon is called the Cambrian explosion, and it represents one of the most perplexing transitions in the history of life on Earth, a moment when the diversity and complexity of visible life seems to leap forward in ways that challenge our conventional understanding of how evolution typically operates through gradual, incremental changes across vast stretches of time. The psychological mechanism that keeps this mystery alive in our collective consciousness is our deep human need to explain origins and transitions, to trace clear lineages and understand cause and effect. Yet the Cambrian explosion resists such neat narratives because the fossil record simply does not preserve the intermediate forms that Darwinian evolution would seem to require, leaving us with a gap that cannot be easily dismissed or fully bridged. Scientists have proposed numerous explanations, including the development of new ecological niches, changes in atmospheric oxygen levels, the evolution of predation as a driving force, and genetic innovations that allowed for greater body complexity. Yet none of these theories completely resolves the tension between what we observe in the rocks and what our theoretical framework would predict. Imagine standing on the deck of a ship during a violent electrical storm, the sky pregnant with dark clouds and the air crackling with invisible energy, when suddenly you notice something almost impossible: a faint, ghostly glow beginning to dance across the metal mast above your head, a luminous crown of pale blue or violet light that seems to float and flicker with an otherworldly presence. And in that moment of terror and wonder, you are witnessing one of the most inexplicable phenomena in maritime history, a manifestation that sailors have feared and mythologized for centuries. St. Elmo's fire, named after the patron saint of sailors, appears as a glowing plasma corona that forms around pointed objects like ship masts, airplane fuselages, mountain peaks, or even the horns of livestock during thunderstorms, and the phenomenon creates an almost sentient quality, as if the light possesses intention and awareness, hovering with an eerie consciousness that defies simple categorization. The scientific explanation suggests that during electrical storms, when the electric field becomes sufficiently intense near a pointed conductor, the air around that object ionizes. Electrons are stripped from air molecules, creating a luminous plasma discharge that emits that characteristic pale glow. Yet this explanation, while technically sound, fails to capture the profound mystery of why this particular phenomenon has inspired such deep psychological and cultural responses across human civilization. Sailors interpreted St. Elmo's fire as a divine sign, sometimes indicating protection from the saint himself, while other cultures saw it as an omen of death or supernatural intervention. And despite our modern understanding of plasma physics and electrical discharge, we still find ourselves unable to fully normalize or destigmatize the experience, as if the glow carries within it something that transcends pure physics. Deep within the nucleus of nearly every cell in your body lies a profound mystery that has puzzled geneticists for decades, and it concerns the vast majority of your own genetic code that appears to serve no obvious purpose whatsoever. When scientists first began mapping the human genome in the late 20th century, they made a startling discovery that fundamentally challenged their understanding of how life actually works. Approximately 98% of your DNA does not code for proteins, those essential molecular machines that build and maintain your physical body. This staggering proportion of seemingly useless genetic material became known as non-coding DNA, and it remains one of the most humbling reminders of how little we truly understand about the mechanisms underlying our own existence. For decades, researchers dismissed these stretches of genetic sequence as junk DNA, evolutionary leftover material that served no real function, merely accumulated debris from millions of years of biological history that natural selection had failed to remove. Yet as technology advanced and scientists developed more sophisticated tools for studying genetic expression, a troubling realization began to emerge. This non-coding DNA was far more active and influential than anyone had previously imagined. Researchers discovered that these supposedly inert sequences regulate when and how genes are turned on and off. They influence the three-dimensional folding of chromosomes. They contain instructions for manufacturing critical regulatory molecules, and they appear to orchestrate complex developmental processes in ways that remain only partially understood. The psychological mechanism behind our normalization of this mystery relates directly to our human tendency to compartmentalize information we cannot fully explain into categories we can manage intellectually. We created the term junk DNA and told ourselves we had solved the problem through naming it, even as evidence accumulated that this dismissal was fundamentally incorrect. Imagine standing at the edge of the ocean during sunset or sunrise, watching the sun descend toward or rise from the horizon. When in that final moment before the sun disappears completely or just after it emerges, a brilliant flash of green light illuminates the sky for just a fraction of a second, lasting anywhere from a single heartbeat to perhaps 5 seconds at most, a phenomenon that sailors and coastal observers have reported witnessing for centuries. Describing it with such consistency and specificity that it cannot be dismissed as mere hallucination or collective delusion, yet remains frustratingly difficult to photograph or capture with precision. The green flash occurs due to atmospheric refraction, the bending of light as it passes through layers of air with different temperatures and densities near the horizon, which separates sunlight into its component colors much like a prism does, causing the shorter blue wavelengths to scatter away while the longer red wavelengths bend downward beneath the horizon, theoretically leaving only the middle wavelengths of green and yellow visible in that final moment. A scientific explanation that accounts for the phenomenon quite elegantly and comprehensively. Yet despite this understanding, the green flash remains elusive and unpredictable, sometimes appearing vividly to observers standing in the exact same location where others see nothing at all, sometimes manifesting to the naked eye when atmospheric conditions align perfectly, sometimes remaining invisible to direct observation but appearing in photographs taken with the proper filters and equipment, creating an uncanny disconnect between what witnesses claim to experience and what instruments can reliably capture, leaving us in the strange position of knowing exactly why the green flash should theoretically occur, while simultaneously struggling to witness it consistently or explain why it appears so differently to different observers under seemingly identical conditions. Imagine possessing a memory so vivid and detailed that you can recall nearly every single day of your life with crystalline clarity, as if watching a film reel of your own existence play backward through time. This is the experience of hyperthymesia, a neurological condition so rare that fewer than 100 confirmed cases exist worldwide, yet so profound that it fundamentally challenges our understanding of how human memory should function. People with this condition can tell you what they ate for breakfast on a random Tuesday 7 years ago, describe the weather patterns of specific dates from their childhood with meteorological accuracy, and recall conversations with such precision that they can repeat dialogue word for word, including pauses and inflections. They experience their own lives as an exhaustive archive, where every moment is indexed and retrievable, creating an autobiographical memory that operates at a level of detail that seems almost superhuman in its scope and fidelity. The mechanism behind hyperthymesia appears to involve structural and functional differences in specific brain regions, particularly those associated with memory consolidation and emotional processing, though neuroscientists remain uncertain about the precise neurobiological pathways that enable this extraordinary retention. Brain imaging studies suggest that individuals with hyperthymesia may have enhanced connectivity between areas responsible for memory storage and those governing emotional significance, meaning that their brains automatically encode experiences with heightened salience, tagging nearly every moment as important enough to preserve. Yet despite our growing knowledge of brain structure and function, we still cannot fully explain why some people's minds organize themselves in this anomalous way, nor can we reliably predict or artificially induce such abilities in others. Across the deserts of the world, from the Sahara to the American Southwest to the vast dunes of China and the Arabian Peninsula, there exists a phenomenon that has bewildered travelers and scientists for centuries. The spontaneous production of sound from sand dunes themselves, a haunting musical tone that emerges seemingly without any visible source of vibration or disturbance. These singing sands produce low-frequency humming sounds, sometimes described as booming or roaring, that can reach volumes of over 100 decibels, loud enough to be heard from considerable distances away and powerful enough to create a physical sensation in the chest of those standing nearby. The sounds often occur without warning, triggered by nothing more than a footstep, a landslide, or the simple shifting of sand as gravity works upon the accumulated grains on a steep slope. Yet the exact mechanism remains frustratingly unclear despite decades of scientific investigation and countless theories proposed by researchers studying the phenomenon. Scientists have proposed that the sounds emerge from friction between sand grains as they slide past one another, a mechanical explanation that seems logical on its surface. And yet this theory fails to account for why singing sands are so rare, why certain dunes produce sounds while identical dunes nearby remain silent, why the frequency and tone remain so consistent and pure rather than chaotic, and why the phenomenon seems to require very specific conditions of moisture, grain size, and mineral composition that we still do not fully understand or reliably predict. The accepted explanation focuses on grain cohesion and resonance, suggesting that sand grains of particular sizes and shapes, when moving together in coordinated motion, create acoustic vibrations that amplify through the mass of sand itself. Yet this explanation has never been conclusively demonstrated in laboratory settings, and the exact parameters that make one dune sing while another remains mute continue to elude comprehensive scientific documentation. Consider the curious statistical anomaly that persists across human populations. Approximately 10% of people are left-handed, a proportion that has remained remarkably stable throughout recorded history and across virtually every culture on Earth, despite centuries of social pressure, educational intervention, and deliberate suppression attempting to eliminate the trait entirely. When we examine the biology underlying this phenomenon, we find ourselves confronted with a puzzle that neuroscience still struggles to fully articulate. For while we know that handedness correlates with hemispheric dominance in the brain, with left-handed individuals typically showing atypical patterns of cerebral lateralization, the actual genetic mechanisms determining why some brains develop this inverted configuration remain frustratingly opaque and resistant to simple explanation. The mysterious aspect deepens when we consider that left-handedness shows no clear evolutionary disadvantage. Yet natural selection has apparently maintained this minority status across millennia rather than allowing it to disappear or increase to dominance, suggesting some subtle biological equilibrium we do not yet understand. What is perhaps most perplexing is that despite our modern scientific sophistication, we have still not definitively answered the most basic questions about left-handedness. Whether it stems from a single genetic factor or multiple interacting genes, whether prenatal hormone exposure plays a determining role, whether random developmental chance contributes significantly, or whether some combination of all these factors conspires to produce the phenomenon. Throughout history, societies have treated left-handedness as something requiring correction, yet the trait persists with stubborn consistency, and today we have normalized it to the point of casual acceptance, yet we still construct a predominantly right-handed world, from spiral notebooks to computer mice to the basic architecture of classroom desks, as though awaiting the day when left-handedness might finally disappear and justify all our unconscious design choices. In the remote Hesteland Valley of Norway, nestled between steep mountainsides in a region of sparse population and minimal light pollution, witnesses have reported witnessing strange luminous phenomena for decades, with documented sightings dating back to the 1930s, though the most concentrated period of activity occurred during the 1980s when reports spiked dramatically and captured the attention of researchers worldwide. These lights typically manifest as glowing orbs or elongated shapes that move through the night sky with seemingly impossible trajectories, sometimes hovering motionless for extended periods, sometimes accelerating to speeds that defy conventional explanation, sometimes splitting into multiple distinct objects before reconverging as a single unified phenomenon. The lights display a remarkable variety of colors, shifting from white to red to yellow to green, and they often pulse with rhythmic intensity as if responding to some internal mechanism or external stimulus that remains entirely unknown to scientific observers. Hundreds of locals and visiting researchers have documented these events, with some witnesses reporting the lights responding to signal attempts, creating an eerie sense of possible communication or awareness that deepens the mystery considerably. Scientists have proposed numerous conventional explanations, ranging from ball lightning to misidentified aircraft to atmospheric plasma phenomena to geological stress releasing electromagnetic energy from rock formations beneath the valley floor. Yet none of these theories fully account for the consistent, repeated nature of the sightings or the apparent intelligent behavior the lights sometimes display. Consider the remarkable phenomenon of periodical cicadas, insects that emerge from underground in cycles that align precisely with prime numbers, 13 years or 17 years, a pattern so mathematically specific that it seems almost impossible to attribute to random evolutionary pressures alone. These creatures spend nearly their entire lives as nymphs buried beneath the soil, feeding on sap from tree roots in complete darkness. And then, as if responding to some cosmic alarm clock, millions of them simultaneously tunnel upward during a narrow window of time, shed their exoskeletons, and fill the air with their deafening calls for a brief mating season before dying. The synchronization across vast geographical areas is so perfect that scientists have long struggled to explain the mechanism by which individual insects separated by miles of soil and completely isolated from one another could possibly coordinate their emergence with such precision. What makes this phenomenon particularly puzzling is the evolutionary advantage of choosing prime number cycles specifically, since predators cannot easily predict or synchronize their own breeding patterns to match a prime cycle. Yet this explanation still fails to fully account for how the insects themselves generate and maintain such exact timing over generations. The leading theories suggest that temperature thresholds, accumulated heat units, or some form of underground chemical signaling might trigger the mass emergence. Yet when researchers examine these factors in isolation, none seem sufficient to produce the observed mathematical regularity. Even more unsettling is the fact that this pattern persists despite our understanding of insect neurobiology being quite limited, and despite the fact that individual cicadas possess no obvious mechanism for counting years or calculating prime numbers. Consider the peculiar protrusion that exists on the lower face of human beings, a feature so commonplace that we rarely pause to contemplate its profound strangeness. The human chin stands as one of evolution's most bewildering anomalies, a structure that appears to serve no essential biological function, yet persists across our entire species with remarkable consistency. Unlike other primates, who possess relatively flat or sloping lower faces that flow seamlessly into their necks, humans alone develop this distinctive bony projection that juts forward from beneath the mouth, creating an architectural feature that seems almost deliberately placed to catch the light and draw attention to itself. Scientists have puzzled over this for generations, proposing theories that range from sexual selection to thermoregulation to improved biomechanics of speech. Yet none of these explanations adequately account for the chin's existence or its universal presence in human populations. The real mystery deepens when we examine the anatomical mechanics of chewing and eating, functions that theoretically should require no forward projection whatsoever, and yet our jaws have evolved in such a way that we develop not just a chin, but a pronounced one that varies in shape and size across individuals in ways that seem almost decorative rather than functional. We have normalized this feature so completely that we use it as a defining characteristic of human beauty and identity, with entire personality judgments made based on chin prominence, and yet the fundamental question remains unanswered. Why does this structure exist at all? Paleoanthropologists observe that the chin emerged relatively recently in our evolutionary timeline, appearing gradually as our faces shortened and our jaws became less prominent, suggesting that the chin is actually a byproduct of other changes rather than an adaptation in its own right, a sort of architectural accident that our species accepted and incorporated into our self-image. Consider for a moment the strange compartmentalization we have created within human biology, a system of categorization so fundamental that it determines who can receive life from whom, yet remains one of the most poorly understood aspects of our own existence. Blood types emerged as a discovery in the early 1900s when Carl Landsteiner noticed that certain blood samples would clump together when mixed, a phenomenon he could not fully explain but could systematize into the ABO classification system that persists to this day. We have since added Rh factors, Mn systems, Duffy antigens, and dozens of other blood group classifications, creating an intricate taxonomy of human variation that science treats as established fact while simultaneously remaining puzzled by its fundamental origins and purposes. The psychological mechanism behind our acceptance of blood types lies in our tendency to trust empirical observation without requiring complete understanding. We see that the reactions occur consistently, we measure them, we organize them, and we accept them as natural law without necessarily grasping why these specific protein markers exist on our red blood cells in the first place or what evolutionary advantage they conferred. We have normalized this arbitrary-seeming division of humanity into four primary categories, assigning personality traits to them in some cultures, destiny-determining qualities in others, all while our medical establishment relies upon them for survival without ever truly explaining why evolution would bother creating such a complex and occasionally deadly incompatibility system among members of the same species. The fact that a mother and child might be born with incompatible blood types, leading to hemolytic disease in newborns, represents a biological paradox we have medicalized rather than understood, treating the symptoms while the underlying reason for such a design flaw remains suspended in scientific uncertainty.